get through it. Yeah,
Give it to you in 2 sentences.
it's like that's crazy. Okay, so that's working.
Works.
I found these like.
The Thunderbolt ones for the phone.
Yeah, the ones to actually communicate. Like sometimes, like I found where I connect them up to the HDMI, and they won't.
Yeah, I've seen that. So you gotta plug them. You gotta see it one of the ones.
Yeah.
Cause I carry it around. Cause I do the same thing. I test it with my phone and my iPad or whatever. You just it's like
Yeah.
I don't need to carry a laptop around with me all day. I'm not going to. This thing's heavy as hell.
Yeah.
It's like so I just carry it on that. So
Did you bring your like laptop at home?
everything's giving me when I got here.
Yeah,
Check 1, 2, 3, 4. Hey, hey. This is an audio test. Check 1, 2. This is a captioning test. Test 1, 2. Okay.
It's not good. Not plugged in all the way? Well. Okay. Cool.
Let's see. Seems like it's been working okay, right? Yeah, so far. Fingers crossed. Something's happening. Okay, looks good, I guess. Yours must be in European time zone. Oh yeah, it is. I forgot to change it, so it reminds me of my jet lag every time. It's so annoying. So the sound also automatically works, I assume.
Sometimes that goes through the HDMI cable. So it
Okay. Let's try it. Yeah. What else do I want to try? Video.
Volume control for the room itself is over at the touch panel on that green desk. If you
Oh,
want
yeah.
to go louder.
Over there, right? Yeah. Okay. But I think it should be fine. Yep, this works too. Perfect. Let's see. Present review. Never used it before. Oh, no, it's doing funny stuff. Never mind, never mind. I trust it.
hear all three of them at the same time, but we're gonna, I'll stop interrupting. Keep psyching yourself up. Yeah, exactly. That's true. Yeah, it's basically a done deal at this point. Yeah.
Hi all. So our next speaker is Kaius Sinimäki from the University of Helsinki. Kaius is a typologist who's worked with great depth on complexity trade-offs and how processing constraints can give rise to language universals through historical change. He's working to bridge the gap between experimental and typological methods. Let's welcome Kaius Sinimäki.
Thank you. It's a great pleasure being here. As Richard said, my background is in language typology, and I've especially been interested in the interaction between word order, case marking, and agreements. And I started in this journey 2004 and built a database of about 800 languages, but I crucially left out creoles. So I'm very happy to come back to this question now and focusing on creoles and their word order and argument marking patterns and what we can learn from them. We know that languages are transmitted in various social conditions, and usually languages are faithfully passed from one generation to another with some restructuring depending on the degree of language contact and other things. Well, some languages are developed under heavy language contacts, and there may be, or sometimes not, break in normal transmission from a generation to the next. With restructuring, structural simplification, sometimes complexification, but usually quite a lot of different things going on. So as a result, we get pidgins, jargons, creoles, mixed languages, and different heavy contact languages like these. But now focusing on Creole specifically, it has puzzled many researchers why especially Creole languages seem to share many features regardless of the differences in the contributing languages. So regardless that there are many different superstrates, those that are main lexifiers of Creoles, or the substrates which usually contribute much of the grammar of Creoles. So are these similarities due to socio-historic context, because of cognitive constraints or preferences, or what are the reasons really? Now there are several different theories that how Creoles are formed. I just name two, or bring to your attention two different sets of theories. One of those takes the approach that Creoles are vernacalized developments from pidgins. So that first we have pidgins, and then they are learned by children, and that's the way how they developed as Creoles. So there is some kind of a proto-language stage on the road to a full language stage. Crucially, this set of theories tends to argue that there is some kind of a Creole prototype, that once a pidgin changes into a Creole, they share some commonalities, these Creoles, because of they have been derived from pidgins. And pidgins, we know that they are radically simplified communication systems. So there is a tendency of thinking about Creole profile or Creole prototype in this set of theories. Then quite different approach to Creoles is that Creoles are mostly distinguishable from other languages on the basis of their socio-historic background, not because of any Creole profile or that they would share a set of grammatical features. That basically Creoles behave like any other language, that we can't set them apart from other languages. Now, what does the typological data suggest? An increasing number of people have started to look at this question using large databases of Creoles and non-Creoles, and there is an increasing, not consensus, but there's increasing evidence that Creoles differ from other languages. So here's, for instance, a graph from Michal Siso's work a few years back. He took data from the World Atlas of Language Structures and also from the Atlas of Pidgin and Creole Language Structures. 46 grammatical features were used for this particular graph. So here we have the Waltz languages, and here we have the Creoles. There are some Creoles that are grouped with the Waltz languages, and then there are some Waltz languages that are grouped with Creoles. But it is a striking grouping that you get. So this would amount to quite strong evidence for some kind of a Creole profile. But I'll come back to this question later. So because of these grammatical similarities among Creoles, Creoles have also been used to argue things about language evolution, especially about this shift from the proto-language stage to the full language stage. The basic idea here is that Creoles are used in language evolution research because they are thought to form this Creole profile. And that's the I would say that the crucial idea behind of using Creoles in language evolution research. Now, I want to focus on case marking and word order of Creoles. Case marking and word order of Creoles, they are often such features that when people talk about Creole profile or Creole prototype, they refer to the fact that many Creoles have SVO word order, many Creoles, most Creoles lack case marking and agreements, and so on. So here's an example from Stranan. My purpose in this talk is to compare Creoles to other languages, to Pidgins, and then to non-contact varieties, so regular languages. So my data for Pidgins and Creoles come from the Atlas of Pidgin and Creole Language Structures. This APIX database has data for 75 languages on 130 structural features. For non-Creoles, I get data for my case marking from Balthasar Bickel and his colleagues. That database is a little more than 300 languages. And then for word order, I get data from the walls, from Matthew Dreyer's maps, and then also based on my own data collection. So that's a little less than 900 languages. So fairly good sample to draw inferences from. Now, it's good to keep in mind that in Creolistics, there are no shared criteria. There's no consensus how Creoles and Pidgins should be categorized, how they should be defined. I largely follow here how these languages are categorized and classified in the APIX database, but also in Viveka Velupillai's recent monograph on Pidgins, Creoles, and mixed languages. So Pidgins have only second language users and limited domains of use, usually related to trade, buying, selling, things like that. Whereas Creoles, they are native languages, they have a heavy contact background, and because they are native languages, they are used in all domains that native languages are used. Then there are what is called extended Pidgins, or so-called Pidgin Creoles, that emerge as Pidgins, but their domains of use have been extended to cover basically all kinds of usages. So these kind of extended Pidgins can be lingua francas, they can be even official languages of different countries, and they may have native speakers also. But the crucial thing is that they started off as Pidgins, as having only second language users. And I group these extended Pidgins here with other Pidgins, not with Creoles. So here are the sample Creoles and Pidgins. So the red ones are the sample Creoles, the blue ones are the extended Pidgins, and the black ones are the Pidgins from the APIX database. A few words about statistical methods should be said before continuing. The confounding effects of inheritance and diffusion, so whether languages belong to the same language family or whether they are neighboring languages, these are of course factors that have to be dealt with in one way or another in typological research. The classical practice in typology has been to use sampling, so for instance to sample one language per family, or then to sample many languages from one family, but just to count one data value per family. This is the way Matthew Dreyer, for instance, has done now for more than 20, maybe more than 30 years now. The problem is that there are but the challenge in modeling typological data with methods such as regression is that we have a lot of language families. So for instance, in the AutoTyp database, there are more than 300 language families, or the highest level of taxa in the taxonomy. They call them language stocks. And there are many language isolates, so single-member families. So for instance, in Ethnologue reports there are 86 single-member families, so language isolates. So regardless of the fact that we have, however balanced sample we have, we will end up having language isolates, and that will, that may or may not have effects on our modeling techniques then. So for instance, here I have the data on that's a sample about the case marking. So roughly 400 languages. The number of families is 87. So 4.5 languages from each family on average, but the median is 1. So we can see that most of the families, most of the languages in this sample come from small families. So if we use, for instance, logistic regression, it's impossible to use to build family as a fixed effects in the model. So we have to use some other approaches. One of those approaches is that we can use is mixed effects modeling, and that's what people like Yege and Benson-Windsor, they have used and applied in typology. And I think this is a very helpful and promising approach to test statistical tendencies in typological data, to use mixed effects modeling. So I use this approach and I model family and also geographical area as random slopes. So that enables us to look at how the predictor's effect can vary across language families. And then we can assume that rates of change can vary between different families. So that's very helpful for the modeling. And I use likelihood ratio test to derive p-values in the tests. So mixed effects modeling, it works well for modeling language family as a random sample, although we may have a lot of families in the sample, but not with very complex models. The more complex the model becomes, the less likely the model is going to converge. So for instance, the results that I report here, mostly I used language family as a random slope, but there were a few cases where the models just didn't converge regardless of how I tweaked it and whichever genealogical classification I used. So I model families as the highest taxa in the World Atlas of Language Structures database and geographical areas in either of these two ways, depending on which models converged. So either 10 continents, like here, or 24 areas, like here. I classify creoles in the same family with the main lexifier. So for instance, English-based lexifiers, English-based creoles are grouped as Germanic language or Indo-European languages. So I follow glottolog in this practice and also classify creoles to the geographical regions where they are spoken. I'm not sure how helpful that is, but that's the decision I made. Okay, then to the first case study. So creoles are often claimed to have SVO word order. Yes. So for instance, Berbice Dutch Creole. Its main lexifier is Dutch, which has SVO in main clause and SOV in subordinate clause. The substrate of Berbice Dutch Creole is Kologuma Ijo, which is rigidly SOV, and happens to be, just an anecdote information, one of the very, 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 very few SOV languages with no case and no agreements. So just for your information, very rare. But still, Berbice Dutch Creole is SVO. Okay, how about non-creoles? SOV is more frequent in all major world regions. This is from Matthew Dreyer. So, for instance, in these areas, Africa, Eurasia, Australia, New Guinea, North America, South America, SOV is more frequent than SVO. So there seems to be a preference rather towards SOV in non-Creole languages. And the question then is, do creoles differ from non-creoles with regard to word order? Well, in non-creoles, non-SVO much more preferred. In creoles, SVO preferred. This is the distribution of the sample languages. And no surprise that we get a significant result that yes, if Creole, then more likely SVO. If non-Creole, then more likely non-SVO. So this is not really any news, but I just thought that it's good to lay the ground by making this clear here. Then the second case study. Now here I compare creoles with pidgins. So pidgins are claimed to have more varied word order, behavior of word order than creoles. And especially it's been said that Creoles can have non-SVO word order more often than Creoles do. And the reason for this is that Pidgins tend to reflect the word order of the native speakers' native language, of the speaker's native language. So for instance, Pidgin Hawaiian is referred to here sometimes, that Pidgin Hawaiian is verb initial spoken by the Filipino, SOV spoken by the Japanese, SVO is also used, but the Creole is consistently SVO. So this is just to illustrate that the word order of Pidgin may depend on the native word order of the native language of the speaker. So there is transference here. But that doesn't always happen. So for instance, Chinook Wawa or Chinook jargon is SVO, although its main lexifier, coastal Chinook, is VOS. So, do Pidgins have SVO less often than Creoles have? Well, just looking at the graphs, it seems like maybe. But when doing statistical tests, we can't reject the null hypothesis that Pidgins behave like Creoles here. So Pidgins do not have SVO less often than Creoles do. That's the basic conclusion from this case study. So word order doesn't depend on language type here. So the next case study. Does word order of Pidgins and Creoles depend more likely on the word order of the main lexifier? So this goes back to this case study 2, that Pidgins are claimed to reflect the word order of the language of the native speakers, whereas Creoles not. So I test this also. So the dark bar here means that the word order of Creoles here is the same as lexifier, the light here, that the word order is different from the lexifier, and the same for Pidgins. And it seems like, just looking at this graph again, that there is a tendency for Creoles to well, there's actually a sort of a backward tendency here, that Creoles tend to have the same word order as the lexifier more often than Pidgins do, which is actually quite striking. But again, we cannot reject the null hypothesis that there would be any difference between Pidgins and Creoles. So word order of Creoles depends on the word order of the main lexifier. Word order of Pidgins differs from the main lexifier more often, but the null hypothesis is still retained. Let's then move on to look at how case word order and language type interact here. So up until now, I have mostly focused on just word order, but now I bring in case also. Because in language typological research, it has quite clearly been shown that word order correlates with patterns of argument marking. So Balthasar Bickel, for instance, well, this has been shown since early 20th century, but just during the past 10, 15 years using modern statistical methods and sampling techniques. So one of these conclusions has been that verb final order attracts case marking of arguments more than languages with some other word orders do. And then I also showed in my earlier publication that SVO word order attracts what I call zero marking. So zero marking here means that there is no case marking and no agreements in the transitive clause. So there are these quite strong correlations between argument marking and word order across languages. Creoles are also said to have case marking very rarely. Some Creoles do have case marking, but the majority don't. So the question here is now that do Creoles pattern like non-Creoles here? Or if we think about the relationship between word order and argument marking in Creoles, is there a stronger relationship between word order and case marking in Creoles compared to non-Creoles? So that's what I would like to find out, and I report some initial results here. So first, Creoles. yes, there is quite a strong dependence between word order and argument marking, so that SVO correlates with no case marking. Well, not particularly big news. But then, how about non-creoles? This is a sample of the 300 plus non-creole languages. Again, correlation between word order and case marking, so that SVO languages tend to have case less often than non-SVO languages do. But then how about when we put these together in the same model and look at the dependence of, or the interaction between case, word order, and language type. So language type here meaning Creole versus non-Creole. So based on this modeling, it seems that there is not enough evidence to reject the null hypothesis that Creoles behave like non-Creoles. So back to the Creole profile. Like I said earlier during the talk, there is increasing amount of empirical evidence that Creoles differ from non-Creoles. But crucially, the grammatical structure of Creoles depends strongly on the major lexifier languages. So Creoles are not independent of their ancestor languages, and this is what I intended to show with the case studies. So in this respect, Creoles behave like non-Creoles. So at least with respect to word order and case marking, we can't use Creoles as examples of any, or evidence for any Creole profile or Creole prototype. To me, it rather seems increasingly clear that the Creole profile that we can actually show using typological data, that it may be an epiphenomenon of the lexifier's typological profile. So that the lexifiers are so different from any other languages in the world. The lexifiers of Creoles are largely Indo-European or then Austronesian, and a few others, but usually Indo-European and Austronesian. So as a conclusion, SVO word order is preferred in Creoles, but pidgins are no different. SVO also preferred there, or there is no statistical difference between Creoles and pidgins here. Word order in pidgins also tends to depend on the major lexifier, but so does the word order of Creoles. So again, no difference between pidgins and Creoles there when we look at this from a statistical perspective. And then distribution of word order and case marking does not differ statistically between Creoles and non-Creoles. So with regard to these two grammatical features, there's no evidence for a distinct Creole profile, but rather maybe some evidence for a profile of isolating languages rather, but not for Creole profile. Now, what are the consequences on language evolution research? So if it seems that empirical evidence does not make Creoles special in that regard. And so it seems that we can't use their typological profiles as evidence for arguing something about language evolution. But Creoles, of course, they provide other cues, or may provide other cues about how languages change, especially if we look at their sociolinguistic and larger ecological conditions, how languages change and what factors affect the way languages change. And this research has begun to shift focus to the social circumstances of language change, language diversification, and on linguistic adaptation. So if, let's say during the past 10 years, there has been much more interest on how language structure may adapt to, let's say, sociolinguistic situations of languages or to other environmental factors of languages. But I would rather say that the research that has been done in Creolistics is the baseline where people have drawn ideas, quite a lot of ideas from in this research. So for instance, people have looked at whether language structure adapts to community size or, for instance, to proportion of second language speakers, and so on. So this focus on sociolinguistic context of languages and language change, I think this is a welcome development that increases our understanding of how language structure may adapt or may not adapt to social circumstances. So, thank you.
So we have 30 minutes for questions. I'm going to try the same system again where people with tenure on this side and people without on that side.
Well, first of all, thank you for doing this work. I'm a total non-Creolist, but just based on my general knowledge, Bickerton's original claims obviously weren't just based on word order, but also on the claimed innovations. So, you know, the ordering of tense, mood, and aspect markers, use of serial verbs in Creoles, etc. So do you have anything to say about those features that he proposed as sort of emergent properties of Creoles that had nothing to do with the lexifier languages?
I haven't looked at them myself, but yes, Bickerton didn't just talk about word order and case marking for sure. He talked about various other features as well. So I can't say much about that aspect because I haven't looked at that myself. But I would then again, it would be interesting to look at whether what happens in Creoles with regard to tense aspect, for instance, are those patterns found, or to what degree those patterns are found in other isolating languages also. And my claim would be that yes, for instance, serial verbs are more likely in isolating languages than in non-isolating languages. Of course, they occur in non-isolating languages also, but that's, I would probably follow that line. Yeah.
Hi, I'm Richard Futrell from MIT. So we've heard quite a bit of mentions that talks about emergent sign languages and how they can represent these sort of emergent a priori properties of human languages because they're so new. And there's, I guess, this hope that Creoles would provide a similar thing for spoken language. I'm wondering if, based on your research, we should sort of continue in the hope that that might turn out to be true, or if we should just see them as reflecting sort of properties of the lexifier languages.
Thank you. I would answer in two ways. One is that I'm actually the project that I now have, and I'm hoping to compare sign languages with spoken languages and their argument marking and word order properties, and see whether there is any modality specific or modality independent tendencies in the data. So that's something that I will look into. But maybe as a background, I will also say that if I go back here, just looking at the typological data, starting to look at it roughly 15 years ago, and I was collaborating a little bit with John McWhorter then. I think I started off with the idea then that maybe there is a Creole profile, and maybe Creoles, there is some universal reason for the fact that Creoles have SVO and largely zero marking, not just no case marking, but largely zero marking. But now that I have looked at it myself, I'm not so sure anymore. So I would maybe transfer that to these sign languages also, that maybe we should also be careful and actually research whether we can use them as evidence towards that end or not.
Thanks.
Thank you for bringing to the psycholinguistics community what we can learn from Creoles and Pidgins, and I'd like to turn it around and think a little bit about what we as a community can offer to the study of Creoles and Pidgins. And one thing that comes into my mind is that I think in our community we have a relatively good understanding of the the sort of depth of fine-grained knowledge that is reflected not only in how language is used, but what speakers know about how language is used. Not only about the presence or absence of categorical features like the availability of a particular word order or the presence or absence of a particular tense or aspect marker, but also more quantitative and gradated distributional properties. So if we take, for example, not all SOV languages are the same. Some are rigidly SOV, some have means of moving a noun phrase after the verb under particular types of circumstances. Likewise, there are weight effects that are non-categorical preferences about the relative ordering of constituents, and those are not, although those seem to be very consistently present in different languages, they work differently. In some languages, they move long things before short things, and in other ways, in other languages, they move short things before long things. And I guess I'd like to ask, what is our state of knowledge about these kinds of properties of pidgins and creoles? So that's partly a data question. What do we know, and what could we possibly get? And do you think that that would be an interesting direction potentially for studying? Because also those are sort of those kind of gradations are things that can emerge in relatively short periods of time within a language's emergence because it's a quantitative shift rather than a categorical change. And so I guess I'd like to ask, what do we understand and what can we look for in pidgins and creoles regarding this class of sort of facts about language and facts about what people know about language?
That's a good question. I'm not a creolist myself, so I speak a little bit as an outsider also about pidgins and creoles. If we think about, for instance, this Atlas of Pidgin and Creole language structures, that's one of, there are some, there have been some early projects that have brought together people working on creoles and pidgins with the purpose of getting together a database, but this APEX database is up to now by far the largest and most comprehensive. It's not only categorical data, so they have a lot of example sentences there, but not running discourse. So that's lacking, I would say, that large corpora or parallel corpora of creoles and pidgins that we could use for that kind of research. To my knowledge, there are no such corpora in Creole and Pidgin languages. Like we have massive parallel corpora for other languages, but about these languages, I'm not aware of that.
Great, thanks. I'd also like to emphasize that this, of course, this is partly a corpus data collection and analysis issue, but it's also actually an experimental issue. So actually, we as psycholinguists have the tools that we can use to bring in, to create similar analogous controlled conditions across different languages and look whether the languages behave in similar ways, whether the preferences that emerge are similar or different in relatively tightly controlled ways. So that might be one way that we can sort of contribute in a particularly useful way to these studies.
Yeah, that would certainly be true. Yeah, thank you.
Hi, I'm Savi at UCSD. So I was interested because you originally split up the languages into Creoles and non-Creoles. But of course, and I know that you are thinking about this because you mentioned Bentz and Winter and Lupien and Dale. But have you thought about the gradation in terms of contact in the non-Creole languages? So there's all these high contact languages, and of course with the morphological simplicity that has been found in those studies, you'd obviously expect that to have some type of effect on word order. So I want to know if that's a thing that you're looking at next. And also emphasize this idea that Roger just brought up about experimentation and looking at variation in word order, because that's also, I think, a really good way to move forward and something I'm interested in. But anyway, thanks.
Yes, this degree of language contact, that's, of course, it would be very, very nice if we could look at that, but I'm not sure how feasible that would be. And of course, we have languages like that were grouped in this database as non-Creoles. There are languages in that data set also that some people have claimed that they are Creoles, like Hmong, for instance. Some people have said that it's a Creole or Creoloid or something like that. And there are other languages like that with more or less language contact background. But I'm not sure how we could quantify the degree of language contact there.
Well, the way, I don't know if this is the right way to do it, the way that those guys have done it in the past is looking at the number of L2 speakers And so they have some, but I don't know. I agree with you. So that's why I'm curious
Yeah.
about what you think. Okay, awesome.
I've tried that. And I've replicated some of their results by using population size and also the proportion of second language speakers in the community. But it's very difficult to get reliable data on the number of second language speakers, and the sort of reliable data that we get that for maybe some languages in Africa and a bunch of languages in Eurasia. But from New Guinea, Australia, the Americas, hard to get. Yeah.
All right. Let's thank the speaker.
Thank you.
Crazy stuff on the screen the first time I plugged it in.
Our next speaker is Corey Shane. We'll be talking about reading structures from memory, causes difficulty during incremental development.
All right. Okay. Well, hi everyone. I'm Corey from Ohio State. And today I'm going to be presenting some new results on an old idea. And before I get into this, let me first say that the bulk of the work that I'll be presenting today was written up for a workshop this past December. It's cited right there. So there's a lot of detail that in the interest of time I'm going to be skipping over, but it's contained in the write-up for your information. So there's this long-standing hypothesis in the kind of psycholinguistics world that human sentence processors have to retrieve structures from memory in the course of incremental processing, and that doing so is going to come at some sort of processing cost, and that cost is going to be reflected in measurable behaviors, like reading time. And this is a prediction that's made by a number of theories of sentence processing, such as these, and it has been supported by numerous previous studies. This is just a small handful of some prominent ones. So, to conclude, memory retrieval effects exist in human sentence processing. Thank you all for your attention. No, sorry, it was April Fool's. I couldn't resist. But this raises the question of why we're still working on this, right? If we have this accumulation of evidence that people do these retrieval things, that they have some sort of cost, why does this question still matter? The reason for that is that the previous results are more mixed than some people realize. So the results I cited earlier tend to emerge from studies that use constructed stimuli that were written by the experimenters for the purpose of eliciting these kinds of effects, often with attention paid to one particular region of interest within that sentence. Right, but the theories themselves make predictions about general processing costs during regular, everyday run-of-the-mill parsing. So they predict that we should see these same costs when people are reading the newspaper or talking to each other. And that's where the results have been not so clear. There have been lots of studies that have used naturalistic stimuli and kind of tested these same predictions, and there the results have been weak or null in general, in some cases even negative, with a facilitative cost of high memory load. So it's in response to this kind of dilemma, this discrepancy, that our work is situated. And firstly, I'm going to identify a couple of potential confounds that might exist with respect to each type of stimulus. So on the constructed side, where we're seeing what look like memory retrieval costs, we might be seeing some confounding factors that just arise out of the type of stimulus used. In particular, there might be effects with respect to the fact that many of these studies are looking at a particular type of construction. So the results are found with respect to a particular limited domain. They may not generalize to all of sentence processing. The stimuli are also often very weird. If any of you have experience with the stimuli that are used in these studies, they're often hard. They are usually presented in isolation. So there's no discourse context, and people are still required, just by virtue of being people, to try to interpret what they mean. So there could be confounds with respect to kind of processing these weird isolated sentences that don't directly have to do with memory retrieval. And then finally, these studies tend not to control for information theoretic factors, like surprisal, that's been talked about over and over again at this conference, that are known to affect processing, but that don't and may not necessarily have anything to do with memory. But there are weaknesses on the naturally occurring side as well. So these studies tend to require their subjects to read lots and lots and lots of text. That's a big endeavor, and so they tend to use fewer subjects. So there could be confounds with respect to that. There were only 10 subjects that read the widely used Dundee eye tracking corpus that's used in these kinds of studies, and was used, for example, by Denberg and Keller 2008. And then the stimuli might face kind of the opposite problem. They might be too easy. So they weren't written to elicit memory problems. In fact, they were written for the opposite purpose, probably, to be readable and fluent and comprehensible. So it could be that the effects are there, but it's just that they're too small to be revealed by such easy stimuli written for a totally different purpose. In addition to these kinds of considerations, we also have to contend with the fact that while there are many theories about how we're using memory in sentence processing, and while there are things that they share in common, they do make different predictions. So I'm going to focus today on two prominent such theories. The first of these is very well known, especially in this community, and that's the dependency locality theory, which predicts processing cost as a function of the length of the dependencies that you have to compute at a given word. But there's also these other memory-based models that are based on a left corner model of parsing, where cost is predicted as a function of the memory operations that you have to perform, just as a function of the operation of the parser. These predictions make somewhat different theories, or theories make somewhat different predictions. And in addition, the broad kind of frameworks that they outline could be cached out in a number of different plausible ways, and that could have a big impact on the quality of the theory as a predictor of sentence processing. So our work is intended to kind of respond to all these concerns in the following ways. Firstly, we're going to be using a fantastic new corpus put together by folks here at MIT called the Natural Stories Corpus, which we're calling constructed natural. And I'm going to argue later that it occupies a kind of intermediary position between the two extremes I just described of constructed stimuli on the one hand and naturally occurring stimuli on the other. We're going to be doing, in response to kind of the many different ways that these predictors could be cached out, we're going to be doing empirical predictor selection on an exploratory corpus, and then running the best of those predictors on a confirmatory portion of the corpus. And then finally, we're going to be including information theoretic controls in our baseline. So any effects that we're reporting are over and above the effects of 5-gram and PCFG surprising. And under this regime, we do indeed find strong, broad coverage evidence in self-paced reading of both locality-based dependency locality theory effect and a locality-independent left corner effect. I'll talk about that in a second. So here's the roadmap for the rest of the talk. Firstly, I'm going to kind of describe the experiment we used, and then outline each of the theories one by one, and present the results from them. Our experiment, as I mentioned, used the Natural Stories corpus, which contains stimuli that are constructed by experimenters for the purpose of doing psycholinguistic experiments, but they're nevertheless fluent narrative text with lots and lots of discourse context. They do contain a disproportionate representation of memory-intensive constructions in comparison to typical, say, newswire text. So we think that these two properties of the corpus might help mitigate the potential confounds that I outlined earlier. Self-paced reading data were collected over these texts from a lot of people, 181 different subjects, yielding about 850,000 individual reading events. So that's our corpus. We partitioned it into two sets, an exploratory set and a confirmatory set. And so I'm going to stress here that all predictors that we ran were run on the exploratory set first before we peeked at the confirmatory set. So the order of presentation in here might suggest otherwise, but that was the case. And then finally, just kind of as a side, all of the predictors reported here are in spillover 1 position. That appeared to be where the action was happening in the exploratory experiments. So to briefly outline the dependency locality theory, again, it predicts processing difficulty as a function of dependency length, where length is computed as the number of discourse reference that intervene in a given dependency that you have to build. So the intuition behind this is fairly natural. It's that things that are old are going to be harder to retrieve than things that are new. So for simplicity, this rather complex notion of a discourse referent has been implemented in DLT as simply being nouns and finite verbs. So words that are nouns and finite verbs introduce discourse reference always and only. And then an integration cost for each word can be computed, which is the sum of the discourse cost of the word itself. So basically 1 if it's a noun or finite verb, and 0 otherwise. And then a dependency cost, which is going to be the total length in discourse reference of all the dependencies that the word shares with words in its preceding context. So here's a very brief example of the computation for one given dependency. Here we have this complex sentence. Yesterday, the person, supervisors, and coworkers caught stealing millions fled. And there's a dependency from fled back to the subject person. That dependency has 4 bold-faced discourse reference that intervene. So that dependency imputes a cost of 4 to the overall processing of fled. So that's an intuition of how the theory works. We implemented the kind of like vanilla implementation of DLT as described in Gibson 2000. Here are our results on the confirmatory set. As you can see, we have a highly reliable effect. The effect size is quite small, only half a millisecond for each unit of DLT integration cost. But nonetheless, we believe that this is a quite reliable effect of DLT integration cost on reading times. Now, in addition to this vanilla implementation, there were a number of other possible implementations of the theory that we considered, motivated by independent considerations. For example, we thought that coordination and preceding modifier dependencies might be introducing long dependencies and exaggerating the costs attributed by DLT to particular words, even though those dependencies may not be particularly hard to process. We tried out a variety of different implementations or modifications to the implementation of DLT on exploratory and selected the best of these for evaluation on the confirmatory data set, and the results substantially improved in comparison to the kind of vanilla DLT implementation with a really quite massive improvement in model fit by including this predictor. This is likelihood ratio testing of mixed effects models. And an increase in the estimated effect size. So we believe, to our knowledge, that this is the first strong evidence of a DLT effect in broad coverage sentence processing. But we also considered these left corner models in addition to DLT. Unfortunately, describing these is somewhat complicated, so I'm going to be very brief here. Speaking at a high level, these are a popular model of sentence processing that have been argued for a long time to be cognitively plausible. And a left corner parser maintains a store of derivation fragments that consist of active categories A lacking a weighted categories B that it expects yet to come. It needs a weighted category B in order to complete A. And it can keep track of as many of these separate disjoint derivation fragments as it needs, depending on the level of recursion in the parse that it's currently building. And it builds up a phrase structure tree by incrementally forking off and joining up these fragments and updating its predictions about the categories that it's building. As I mentioned, it's a fairly complicated model. In the interest of time, I'm not going to go through all of the details. I'm just going to show you a very brief and incomplete example to try to, again, establish some intuition. Imagine that we're parsing, we're reading something, and we see the word "the," and so we're building a phrase structure tree representation of the syntax of the sentence that we're reading. Having seen "the," we expect that we're building a noun phrase. We also expect that we need a noun in order to complete our noun phrase. So our active category is NP, and our awaited category is N. Now, let's say the next word we observe is dog. Well, it happens to be the case that we know that dog is a noun, so we can kind of build this link here. We've satisfied our awaited category. We can complete our active category. And now, in order to continue parsing, we need to update that active category. So we have to retrieve it from memory in order to update the representation that we're building and continue parsing happily along our way. So let me stress that we might not have seen dog, right? We might have seen blue, in which case we wouldn't be able to build this connection and complete our category. Instead, we'd have to somehow integrate blue into our representation and then continue looking for our noun phrase. So that's an example of how memory retrieval is going to be predicted by this model of sentence processing. Again, as in the case of DLT, there are many plausible implementations of predictors within this general framework. We tested out a lot of them on the exploratory data set. And the best one turned out to be one that we're calling no fork. The origins of this name don't matter, but what matters is what it predicts, which is namely that there's going to be a retrieval cost whenever the top sign of the category that you're building needs to be retrieved and updated, as I showed in the example. And it also happens to be the case that this occurs exactly when you arrive at the right edge of a constituent. So you can perhaps more intuitively conceptualize this predictor as being a flag on the right edges of constituents. When the constituent ends, you have a retrieval operation as predicted by this particular model of sentence processing. And so I'm going to stress that this is a Boolean predictor. It's just there or not. So as compared to the DLT, which is locality-based, this just simply predicts a cost as a function of whether or not you perform a retrieval operation. And so here is our left corner result. In comparison to the DLT results, we get a very large contribution to model fit reflected in our low p-value, and a relatively large effect estimate. But again, we're looking at small effect sizes in comparison to many other kind of known contributors to processing difficulty. So the effects that we're observing are reliable and robust, but also faint. And I think that's going to be important for interpreting the lack of such results in previous studies. But nonetheless, we find results that are quite reliable for a left corner effect as well in broad coverage sentence processing. Now, I want to say a couple things about the interpretation here. Again, as I stressed, the left corner predictor is Boolean. So this effect estimate is the entire effect. It's either there or not, that 4 millisecond cost. Whereas the DLT effect is continuous, it ranges over values, and so it's going to be multiplied by its effect estimate. In principle, this can be quite high. In our corpus, the modified DLT cost reaches 12. That's the max. But is usually pretty small. For the 95th percentile is 2. So for most words, you have a fairly low DLT cost. What this means is that our model is predicting, in general, a larger left corner effect for the majority of words in the corpus, but in cases where you have a large DLT cost, it predicts a larger DLT effect. So this is kind of strange. We seem to have separate effects arising from, or two different effects arising from models that are usually construed of or thought of as competing with each other. Maybe gently competing, right? So they're based on this same notion of retrieving stuff from memory, but they make very different predictions about how memory is used. Maybe they're measuring the same thing, right? So we tested this possibility using what we're calling a diamond likelihood ratio test, where we fit 4 different mixed effects models. 1, the baseline model, which included neither predictor, 2, which included one predictor but not the other, and the both model, which included both, and then compared them statistically in the way described in this diagram, and all comparisons are significant. So that means that the individual models improve significantly over the baseline, and the both models improve significantly over each individual model. So these appear to be making strong independent contributions to model fit. It appears to be the case that the effects we're observing are not the same thing. And a second follow-up question we had was whether these effects are widespread. So they're strong enough to give rise to an effect that's visible overall in the system, but they could still be driven by particular kinds of contexts. I'm going to say at the outset that we can't rule this out. There are lots of ways in which you might think that context could be affecting the results that we're getting, but we did focus in a follow-up analysis on one plausible such context, which was found by Denberg and Keller to be the case for DLT, and that's that the DLT effect in Denberg and Keller, 2008, was driven by nouns and verbs. In their case, they didn't find a generalized broad coverage effect, but they found it when they restricted their analysis to nouns and verbs. So we did the opposite thing. We removed nouns and verbs from our analysis to see whether or not the effects that we found survive. And it turns out to be the case that the DLT effect doesn't. It's still, it winds up being not significant if you remove nouns and verbs. So it appears to be that the DLT effect we're observing is driven by the processing of nouns and verbs. However, the left corner effect remains quite robust. So this appears to be, at least with respect to this manipulation, a generalized kind of structural effect. So to conclude, the main contribution of our work here is that we believe we found the first strong broad coverage evidence, or evidence of broad coverage memory effects in human sentence processing. And so this is nice because it kind of supports the existence of theoretical objects from linguistic theory like constituency and or dependency. It seems like people have something like this in the brain, and that it is affecting the way that they process sentences. And then we also have this kind of outstanding question of there being 2 separate effects for models that that were originally construed of as being in competition. I'm going to engage in some wild speculation at this point, and say that these might have to do with differential processing of semantics and syntax. So it could be the case that the DLT effect we're observing is related to constructing semantic dependencies or computing semantic information, while the left corner effect is due to syntax. The reasons I suspect this is that the DLT has access to semantic information that is not available to the computation of the left corner predictor. So the DLT, for example, or there tends to be kind of a close relationship between semantic and syntactic dependencies. Although the DLT is articulated in syntactic terms, it may be detecting effects related to computing semantic relationships between reference. And then also it has direct access to this idea of referential status through the noun-verb other distinction that it makes, where nouns and verbs are assumed to contribute discourse reference and other words are not. So there seems to be this kind of potentially semantic information available to or embedded in the definition of DLT integration cost. In the case of the left corner parser, the predictor is simply a matter of tree configurations. The way the tree configurations are manipulated, it's simply a question of, are we at the right edge of a constituent or not? And then, yeah, so also in our follow-up study that I mentioned, the DLT effect appears to be driven by nouns and verbs, which again have this potentially asymmetrical semantic status in comparison to other things, in that they might be introducing discourse reference, potentially again supporting a semantics versus syntax distinction in interpreting these two effects. So that's the speculation that I will leave you with, and at this point I'd just like to thank our various funders and you for your attention. Thank you very much.
Right. Am I even in the right location? I don't know. So, okay. Hi. So that was great. One question about the left corner thing.
Mm-hmm.
So for you, this is a retrieval thing that is going on, right? What if it's a storage cost? Like, I've completed the constituent and now, like, I'm transferring it to memory somehow, because there's at least one parsing model that I know of which says that as soon as you complete a constituent, it goes into memory where you can retrieve it later.
I'd need to think about that. So a left corner parsing model would assume that that sign has already been created in memory and its representation needs to be updated at that point. It would require a different model of parsing to make that claim, but
right,
I suppose that it's possible.
Right, but descriptively it's just, you said it's the edge of a constituent.
It's the right edge of a constituent, yeah.
Right, okay, thanks.
I might have to pause. Jerry Altman is sending me texts. He's shooting me lines. So I was wondering, why not use an empirically grounded measure of retrieval rather than, making guesses about what retrieval, when retrieval is involved, and what costs there might be with retrieval in both the DLT or the left corner parse case. So, we know that first of all, retrieval costs, when an item has to be retrieved, it engenders about 100 millisecond costs. That's true about long distance dependencies, or it's true in Andrea Martin's work with ellipsis and so forth. So that's a very robust cost in terms of time. And we know, for example, with work with Matt Wagers and I, about when a constituent is outside of focal attention and when it requires retrieval. For example, a modifier, like a PP modifier of a DP, won't displace an item from focal attention, so binding to a subject or binding to a verb, right, will not involve a memory cost. But if you interpolate a relative clause modifying that constituent, it will engender a 100 millisecond cost, and so forth. So there's a range of constituents that will displace an item from focal attention and will engender retrieval costs. That seems to make very clear predictions, and it's empirically grounded. It doesn't, of course, incorporate other factors like interference, which may have effects on timing or accuracy, depending on how you want to model them. But at least it's an empirical grounded way rather than storytelling, basically, about when retrieval is involved. Why not use that?
So can you clarify what you mean by empirically grounded methods?
We know when we have behavioral markers of when retrieval is involved. It engenders cost of 100 milliseconds.
Yeah, so you're specifically talking about the duration of the attributed
Well,
cost?
that's a measure from SAT that's also grounded in fMRI by hippocampal involvement and
Right.
so forth.
So that's kind of where I thought you were going with the
It's a behavioral
question.
marker of when retrieval is involved, right? So why not take the results from that, saying when retrieval is involved, and do the calculations here on naturalistic texts, right? That would actually be grounded in what we know about the costs of retrieval and when it's involved.
While my impression is that the specific durations that emerge out of the literature emerge from constructed stimuli, right? So it's possible that there may be durational differences in terms of how expensive retrieval actually is according to context.
Yeah,
in part, that's what the naturalistic study is designed to
right?
explore,
That's why to do
right?
it. Right.
So if the hard claim emerging out of that literature is that retrieval costs 100 milliseconds, our results are not consistent with that, right? The estimate that we're finding.
No, you don't know if they are because you haven't done them. You've taken a model DLT, or you've taken a model of a left corner parse and assumed that calculated your retrieval counts on the basis of that distinction. But in fact, the very left corner parse that you talked about would not involve retrieval on our measures, on the empirical grounded measures. So, I mean, you get a number that's estimated from your guesses or model theoretic choices about when retrieval is involved. That estimate would be rather different if it was calculated on the basis of the empirical grounded times when retrieval is actually involved. You get it?
I think I may have to talk to you afterwards. Yeah, I'm not sure if I understand the distinction that you're drawing.
Sure. So this is maybe a follow-up to that question, actually, which is that the two types of retrieval or integration that you talk about are very, very different in character, right? One of them is this all or none operation. The other is this very, very continuous kind of always occurring, differing in value, kind of continuous measure of difficulty. Those sound like they encode very different models of what human memory is like for language. So I'm wondering, maybe I'm wrong about that. Maybe there's a sense in which you can make both of those fit into the same model, but I'm wondering, what are your predictions about being able to kind of fold both of those into kind of the single human brain? Or maybe kind of what kinds of memory phenomena do you think you're responsible for explaining under this combined system? So, like, supposing it's the case that both of these systems are activating, like what, do you see, I don't know if my question is clear enough.
Yeah, I think that's a really good question, and I wish I had an answer. I think that's kind of like the major source or direction that we would like to go with the remainder of this work. The kind of speculative answer that I gave at the end, which is my answer, is that it may have to do with some difference between retrieval at the semantic level and the syntactic level. I'm not sure to what extent that is like how to provide kind of a mechanistic explanation for that in terms of general purpose memory resources.
I don't know whether they're general or not, but they both emerge from the same computational brain, or same brain, same computational system at some level, right?
Right. I mean, so my answer would be that the computations are different that need to be made.
Okay.
Right.
Okay,
but,
thanks.
yeah.
Following up on that, I was hoping you could say a bit more about why you saw these models as being in competition, because it feels like comparing apples and apple trees. What I had always understood DLT to be was not a claim about what the representations are, but a claim that once you've come up with the relevant representations, whatever they are, here's what you can pull one salient feature out of them and then compute a cost based on that. And that was focusing on a certain type of dependencies that were assumed to be accounting for a lot of the cost. Meanwhile, the left corner models at their core aren't great at tracking the kinds of dependencies that are the focus of DLT. So it seems like they're just, I'm surprised that you felt like there was so much work needed to reconcile them, because they're just things that pick out different parts of the same problem, aren't they?
Well, I mean, I think that given
you
our
don't need to be
results, I have to
syntax
say
semantic.
yes.
But didn't we know that just looking at what the models were designed
Sure.
to do?
Yeah,
Like one of them is mostly going to be dominated by any time you come out of an NP, it cares about, because that's going to be the primary thing you pop out of. And the other one, because it starts with fully built NPs, doesn't care about that.
Right. No, I agree with you. I was potentially over-exaggerating the differences for dramatic effect, since we were ultimately going to say that they are that both effects appear to exist simultaneously in the brain. And I do. I think it's clear that they make different predictions. The predictors are not very well correlated. They make independent contributions to model fit for all the reasons that you just described.
Because they
in left corner, you're
phenomena.
manipulating these tree structures and forking and joining them. It doesn't have anything to do with computing dependencies. I guess I would say that a parsimonious model would ideally only have to make reference to one kind of mechanism or the other. So in that sense, you might potentially consider them to be competing. I don't know. But in the end, I think what you're objecting to is just a matter of framing on my part with the particular presentation and not essential to the result that we found.
Okay, it's pretty short. So this is a question about coverage, and it sort of, it interleaves with what Colin just said, I think. So as you found, and as we found in the Danberg and Keller study, if you take out verbs and nouns, then the effect goes away, essentially. So what's the coverage of DLT in terms of how many words in your data set do you actually get a non-zero prediction for? Because we found that's really just the verbs and some of the nouns. So there's a lot of zero predictions, and that's the reason why we didn't get an overall effect. And I suspect it's similar for the left corner model, where the phrase boundary, the word on the phrase boundary gives you a prediction, everything else is zero. And if you take those two together, then of course you get better coverage. And this is, as Colin said, means the models are complementary. But could you quantify coverage for me, I guess?
Well, the DLT predicts non-zero values all over the place besides just nouns and verbs. So there are lots of other types of things that have dependencies. And nouns and verbs can intervene in those. So a preposition is not going to be a noun or a verb, but if it's situated far away from, say, the verb that it's modifying, its DLT cost can still be quite high. There are a lot of events in the corpus that have, as I mentioned, have a low DLT cost. In some cases, that's because they're nouns and verbs. In other cases, it's because they have a dependency that's of length 1. So I think the coverage of the predictions is rather good for our corpus in terms of where the predictions are non-zero and even when nouns and verbs are removed. It just happens to be the case that the people don't appear to be experiencing a cost there. So it's possible that there are relationships in that sense, but as I mentioned, the predictors are not very well correlated. I think the correlation coefficient is about 0.25 or so. Yeah.
Thank you.
Thank you.
Predictions during natural reading, effects of surprisal and computer
Okay. Fundamental questions about the role of prediction in sentence processing have been around for several decades now, but these questions have been addressed using a variety of different approaches. Most of the early work in this area assessed predictability in terms of close probability, or the proportion of participants who provide a particular target word in response to an initial sentence stem. So here's a classic contrast between a high close and low close target word. And several early experiments have shown that language comprehenders are quite sensitive to manipulations of close probability. So in the eye tracking literature, we tend to see higher skipping rates and shorter fixation durations for high versus low close words. And with ERPs, we tend to see reduced in-400 amplitude for high versus low close words. So this approach is, of course, very useful, but it does have some disadvantages. So the traditional practice has been to present a single sentence stem with a target word and to collect close completions at that one point. This can make it time-consuming to generate enough items to run an experiment. And so as a result, the items tend to be highly constraining by design to maximize the difference between the high close and low close conditions. But over the past couple decades, we've seen new approaches to capturing prediction during sentence processing. And in particular, we've seen the development of metrics grounded in information theory. The most common of these that we've heard quite a bit about is surprisal, defined as the negative log probability of a word given its context. And with sophisticated computational language models, we can generate surprisal values very easily for every word in a sentence. And using this approach, we've accumulated quite a bit of evidence pointing to a relationship between surprisal and sentence processing measures. So higher surprisal values are associated with longer reading times, larger in400 amplitude, and increased activation in several language-related brain areas. A different information complexity metric that has received less attention is entropy. And entropy is a way to quantify the degree of uncertainty about what's being communicated as a sentence unfolds. And we can define the entropy of a distribution as a function of the probabilities of the various possible outcomes. So the larger the entropy, the greater the uncertainty about how the sentence will continue. Importantly, though, entropy fluctuates as we encounter each new word in the sentence. And this observation led Hale to propose entropy reduction as a key sentence processing metric. So the idea here is that if entropy is reduced from one word to the next, then uncertainty has been reduced and the comprehender has done information processing work. Okay. A handful of studies have looked at the joint contribution of surprisal and entropy reduction to sentence processing times. And the consensus seems to be that greater surprisal and greater entropy reduction independently contribute to increased reading times. Notably, these three studies have all used self-paced reading as their dependent measure, and they also all estimate their metrics of surprisal and entropy reduction using some sort of computational sentence parser or other sort of statistical language model. Now, this approach of using a computational model to derive estimates of surprisal and entropy reduction has several advantages. As I've mentioned, we can very easily generate values for every word in a sentence, and this allows us to study prediction across natural sentences that are not artificially constraining. But this approach does have several potential limitations. So first, anytime we select a statistical language model to generate these metrics, we're to some extent making a commitment to a particular theory of language. So decisions have to be made about whether to use a computational parser, a connectionist model. There are potentially other choices to make about what sort of grammar to assume and the parsing algorithm. In addition, the statistical language models have to be trained on a corpus. So this raises additional questions about what an appropriate training corpus should be, how large that corpus should be. And it's often the case that the corpus that's used tends to be very small compared to the vast amount of language experience that adult humans tend to have. And then finally, these models tend to assume that sentences are independent of one another. So a computational parser, for example, will parse a sentence and assign complexity metrics, then take the next sentence and start fresh. So this makes it problematic to use connected texts, where it's almost always the case that sentences in that text relate in meaningful ways to the sentences that have come before. So, as in previous work, the goal of the current study was to examine contributions of surprisal and entropy reduction to reading times, but we did this taking a new approach. So first, we used eye tracking rather than self-paced reading. Eye tracking, of course, gives us a very dynamic measure of sentence processing. It's more natural compared to the semi-artificial nature of pressing a button to reveal each new word. And then we derived our metrics using a cumulative close task. And tasks like this have been used recently by Luke and Christensen and Whitford and T-Tone. And in this task, participants get the first word of a paragraph. And their task is to guess what the most likely next word is. They then see that word, and they have to guess the third word, and so on. So we can then use these closed data to compute measures of surprisal and entropy reduction in a theory-neutral manner without having to make commitments to a particular theory of grammar or worry about parsing algorithms or training on a corpus. And then this allows us to study these processes in naturalistic connected texts. The texts we used were 40 short paragraphs that were adapted from standardized reading comprehension tests. The number of words in these paragraphs ranged from 46 to 77. And we used paragraphs that represented a wide range of difficulty levels. So the Flesch-Kincaid grade levels ranged from 1.8 to 17.46. This is to get a very diverse sample of language in our study. And the cumulative close task was done with 1,600 people on Mechanical Turk. We had 40 who did the task with each of the 40 different paragraphs. And then 32 subjects at UC Davis read these paragraphs in an eye tracker. To compute our metrics, surprisal is computed directly from the close probability at each word. For entropy, remember we're interested in the distribution of guesses at each word about what's coming next. So we computed entropy using the standard formula, and then entropy reduction by computing differences in entropy across pairs of consecutive words. And in line with Hale's proposal, cases where entropy increased from one word to the next were coded as 0 under the assumption that an increase in uncertainty should not affect processing times. And just a note here that the nature of our task means we are looking at next word entropy. People are guessing the single most likely next word. This is opposed to full entropy, which some computational models estimate, that is uncertainty over the entire remainder of the sentence. For the eye tracking portion, we computed 4 standard measures. First fixation duration and single fixation duration represent some of the earliest stages of processing. Gaze duration gets a bit later. It's the sum of all first pass fixations on a word. And then regression path duration incorporates gaze duration, as well as times when the reader goes back to reread what's come before moving on. Our mixed effects models included the fixed effects of word length, word frequency, the difficulty of the text in which the word appeared, so this is the Flesch-Kincaid grade level, surprisal, entropy reduction, and then we also tested for potential interactions between surprisal or entropy reduction with our text difficulty measure to determine whether these metrics operate differently across ranges of text difficulty values. So for first fixation duration, we have significant effects across all of our main effects here. Just highlighting here surprisal, each of the dots here represents a word token from our 40 paragraph corpus here. And we see that as surprisal increases, we see this increase in first fixation duration. We see a similar pattern with entropy reduction, where again, increases in entropy reduction are associated with increases in first fixation duration. But we don't see any interactions between those metrics and our text difficulty measure. The results for single fixation duration look very similar. So again, we have a significant effect of surprisal and of entropy reduction. Once we get a bit later to gaze duration, things look a bit different. We still have this robust effect of surprisal, where again, increases in surprisal are associated with increases in gaze duration. But entropy reduction, although the pattern is the same as what we've seen before, it's not significant in the model. And then finally, once we get to regression path duration, this main effect of text difficulty is no longer significant. We still have our significant effect of surprisal, but entropy reduction still is no longer significant. So this work replicates previous findings that surprisal and entropy reduction both contribute to variation in reading times, but we extend these findings in a couple of new ways. So first, our choice to use eye tracking rather than self-paced reading allows us to examine the time course of these effects. And our results are showing that increases in surprisal are associated with increases in reading times across the eye tracking record, whereas this was not the case for entropy reduction, which may suggest that readers experience longer lasting slowdown when a word is unexpected compared to when a word reduces uncertainty. Second, we found no evidence that either of these measures interacted with our measure of global text difficulty, suggesting that these metrics operate across a range of paragraph difficulty levels. And then finally, whereas previous work has estimated their metrics from computational language models, we estimated ours from human predictability data using a cumulative close task. This again allows us to compute these metrics in a theory-neutral manner. It allows us to use naturalistic sentences as opposed to the artificially constraining sentences that are common in studies using the traditional close method. And then this approach allows us to study sentences in connected texts as opposed to sentences in isolation. So thanks in particular to Nargis Azizi and Taylor Hayes, who helped compile the cumulative close data, members of the Henderson Visual Cognition Lab, the Ferreira Psycholinguistics Lab, and don't forget to come to Davis next year for CUNY 2018. Thanks.
Can your tenured person go first? Is that okay?
I don't know.
I'm tenured too, so.
Okay,
Josh.
Right, great. I have a quick question, which is, so I really like the idea of the cumulative close probability task. Did you compare that to did you compare the results of your closed task to what you would get from, say, a bigram model or a trigram model?
No, we have not done that yet.
Okay.
To answer your question. That's a good suggestion, though.
Technical question followed by theoretical question. Technical question, the entropy reduction measure was, so you have at word I, you have an entropy measure, which is the uncertainty about that word, and then the reduction is, and then you, like once you get I, you have the entropy of I minus 1. Is that your difference, is that difference your measure?
Right, so you move from your current word, you have a distribution of entropy, so you have your entropy value, and then the next word, you compute a new entropy value, so it was the difference between those.
So is word I plus 1 included in the old entropy model? Is it the entropy of the joint I and I plus 1 positions, or just of the I position?
It was just where we're measuring the reading time. It was the amount that that word reduces entropy compared to what's come before it.
Sorry, you're saying the difference between the entropy levels at word I before you get to word I and the entropy level at word I plus 1 before you get to word I plus 1? Is that it?
Yeah, I think so.
Okay, so first of all, I want to clarify that's totally not what is in the Hale proposal, because the Hale proposal includes, not only is the Hale proposal at the entire sentence, it's also about structures, and further, and crucially, like, the stuff that comes later is also taken into account when you get the earlier entropy measure. So I want to make that clarified. But my theoretical question is, what do you think entropy reduction is? So we have given many theoretical proposals for why surprisal should matter. What is the theoretical proposal for why entropy reduction should matter?
Well, so first I acknowledge that this is not in line exactly with what Hale's proposed. It sort of it's the best way to assess this using the human closed data. But it does get us at some level of prediction that's not just how expected or unexpected is that word, it's a measure of how certain or uncertain are you about what's coming next. I mean, this work and the previous work using self-paced reading suggests that the two are independent contributions, right? I don't know that this work addresses exactly what that's tapping and how different it is, but.
I'm just asking, like, what's the theoretical link between, like, that? There are many, many different measures that you could come up with. And what's the linking hypothesis between, like, what is going on in the mind and why that summary statistic leads to a particular prediction about whether something takes a long time or a short time?
Yeah,
that's the question.
And I don't know that I have a complete answer to that, but yeah, thanks.
All right, my question is maybe looser, right? And it's also about what the goal is of this kind of exercise in theory building, right? So presumably our goal is not to try to predict reading times. We don't even have any real use for that, right? We're trying to predict reading times because we actually want some sort of model of what's happening in human sentence processing. And I guess I'm wondering, like, I loved the cumulative close probability task. I want to use that task, but also that's human beings, right? And so presumably what I think is happening in human sentence processing is not that human beings are sitting there using all of their, I mean, that's a theory within a theory within a theory, you get what I mean?
Yes.
Yeah, like, don't you want to know what the people are doing when they do the closed probability? And wouldn't that be what we think people are doing when they do language comprehension? So doesn't that get circular?
So I think that this gets a different piece to, so as I've said, most of the work that does this sort of approach takes their estimates from computational models that are all coming at this from different angles. I think that it's useful to see what people are doing when people in the cumulative close test have to guess what's the next word, even though we can't isolate what piece of this is their syntactic knowledge from their semantic knowledge. People's actual predictions provides an extra piece to that broader puzzle.
Yeah, it is quick. And it's not even a question. I think I'm answering Roger's question. What's entropy reduction supposed to be? I think and I'd like to get feedback on it, maybe offline afterward. I think what it's supposed to be is the cost of internalizing the information, so reducing the amount of uncertainty, and so therefore it's the cost of that information that reduces that uncertainty being digested by the mind. I think that's what's intended.
Next speaker is Monique Fletcher, presenting a study on grammatical encoding of resultativity.
All right, can you all hear me? Okay, so my name is Monique, and Maria is not present today, but you can see her lovely face on the slide. So I'll do my best to represent the Estonian language to you today. So I'm going to start by playing you a short video clip, so please pay attention. So if we're asked to describe what happened in a simple event video clip like this, there are certain elements in the scene that you need to pay attention to in order to retrieve the relevant pieces of information. For example, it's quite likely that you will comment on the action depicted in this event, as well as the entity, so in this case the actor and the object involved in the event. And you're also quite likely to comment on the temporal and the spatial contours of the event. Now we know that different languages have different means to talk about any of these pieces of the puzzle that make up an event. So my broad interest is generally how does language influence how we process events online and how we memorize them, basically. So the study of cross-linguistic diversity in event cognition has for a large extent studied motion events as a central domain. And people have looked at cross-linguistic variation in the domain of space, for example. So how does the expression of path or manner information in verbs or other material influence how people attend to the relevant aspects of the event scenes? And other studies have looked at diversity in the domain of time, comparing aspectual and non-aspectual languages, and how this may influence the perception of goals of motion events. Now, in a number of these studies, we find effects that are commonly called thinking for speaking effects. So the idea that your attention is influenced by language-specific encoding patterns when we are engaged in a speaking task. But some studies also show that these effects might be more global or more deeply entrenched, and that we see similar attention patterns when we are not engaged in a speaking task. So today we're looking at a different event dimension, namely the encoding of what we've called resultativity. I will explain this in a second. And the language of interest here is Estonian.
It's not even a real language. It's fake. It's a fake language.
Well, I wouldn't really call it a fake language, but rather an alternative language. It's actually... Sorry, I had to do this. Anyway, Estonian is a very interesting language because it encodes information on the results of events obligatorily via grammatical case marking on object nouns. So I will show how the system works with an example. So the first video that I will play now concludes with an object that is only partially affected, so the event has led up to a partial result. Whereas the event that I'm playing now leads to a full result. The object has substantially changed in state in the time span of the video clip. And this is precisely the contrast that is marked linguistically in Estonian, using case marking on object nouns, the Mandarin in this case. So partitive case is used to express the Mandarin in the first event, and accusative case is used to talk about the Mandarin in the second event. All right, so the question is, does this obligatory encoding of event results lead to enhanced visual attention to results of events depicted in scenes when people are watching them online? And is event memory influenced by the linguistic encoding of resultativity? And furthermore, we were interested in the question whether if we find effects of language, is this limited to speaking context? So can we find, again, thinking for speaking effects? Or is it possibly the case that grammar has a more deeply entrenched effect on cognition, and that it also influences what we look at and how we process events when we are not engaged in a speaking task? All right, so in order to address this question, we conducted 2 experiments, a verbal and a non-verbal experiment, with a group of Estonian and a group of Dutch native speakers in each experiment. So in the verbal experiment, people watched a list of video clips and they were asked to describe each of them in a single sentence, addressing the question, what happened in the video? And in the non-verbal task, people were also watching the events, but they were engaged in a distractor task that involved detecting certain sound cues that appeared randomly during the videos. And we tracked their eye movements while they're watching the videos. So after each of these tasks, we conducted a surprise memory task, and we asked participants, how did the videos that you've seen before, how did they end? And I will explain this in a second. In addition, we had a number of control measures tapping into general working memory capacity to ensure that this is similar across the different groups that we tested. All right, so the videos that we use actually showed 2 different types of events, which were highly similar. Resultative events involved a visible change in state, such as the mandarin peeling or the opening of a can or the cutting of a circle from a piece of paper. But we also had a set of non-resultative events that looked very similar. They also involved an object, but the object did not undergo a visible change in state. It was only partially affected or unaffected, such as a person stirring a soup. I will show you an example again in a second. So each of the videos, they were 3 seconds in length, and they could end in 2 ways, basically, in one of 2 ways. So in half of the cases, the video ended showing the action as still ongoing, such as the one here. I hope you can see. So at the end of the video, the action is basically still ongoing. And in the other half of the cases, the action ceases or is finished by the actor. And in the case of resultative events, this alternation triggers a difference in case marking in Estonian. So a similar manipulation was applied to non-resultative events. So here you see the stirring of the soup, and then the video stops, but it implies that the action is still ongoing. And in the ceased or finished part, the spoon is taken out and the action is finished, basically. And here the critical thing is that this difference between ceased and ongoing does not lead to a case alternation in Estonian, because in both cases, the end result is a partially affected object, basically. So we're not going to look at the difference between ceased and ongoing, but we're using this to trigger case alternation in Estonian participants. And as you saw, the information on whether or not an event will reach a full result, this only becomes available during the final phases of the event's unfolding, so the final frames of the video clip. So we hypothesized that our Estonian participants would allocate more attention and would look more carefully at the action and the object depicted in the videos during this phase of the event compared to Dutch speakers, because for them it's critical for a linguistic choice that they have to make. Okay, so we analyzed the looks in the area of the scene encompassing the ongoing action and the object during the last 600 milliseconds of the videos, which is when the critical information on event results becomes clear. And in the recall task, we used 2 alternative voice choice tasks. So we showed people 2 screenshots, one of the action ongoing and one of the action being finished. So you see here the can is still being opened, whereas in the finished version the can is open. And we asked them, which one did you see before? How did the video end? So we're tapping into accuracy of the participants' recall of how the events had ended. And we're expecting here that Estonians would be better at remembering how events had ended. Yep. Okay, so quickly for the description patterns, we found indeed that Estonian participants consistently marked the object nouns with the appropriate case markers, and we did not see any patterns in the Dutch data to convey this information systematically. They basically did not really care about it. And we did not find any group differences on our control measures. As for the attention patterns, so I'm going to show you now the proportion of looks in the action and object region, so the circled region in the screenshot above, during these last event phases, the last 600 milliseconds. So I'll start with the results from the verbal experiment, so the description experiment. So what you see here is the results for resultative and non-resultative events. And the black bars represent Dutch data and the gray bars the Estonian data. And what we're finding is a main effect of event type. So people allocated more attention to the action and the object when they were dealing with a resultative event compared to a non-resultative event. But we also find a main effect of language. So speakers of Estonian attended more strongly to the action and the object than the Dutch participants in both resultative and non-resultative events. So generally, event endings were more interesting to them. Turning then to the non-verbal experiment, what we're finding here is only a main effect of event type. So again, resultative events triggered more looks than non-resultative events. As you see, there is a tendency for an interaction of in the data, but it did not reach significance. Turning now to the results for memory accuracy. So this is the proportion of accurate responses. What we're seeing here is a main effect of language, showing that Estonian speakers were overall more accurate at remembering how the videos had ended than the Dutch participants. However, if we now turn to the non-verbal experiment, we find something that we did not expect, namely the opposite pattern. So in the non-verbal condition, Dutch participants all of a sudden recalled the ending of events better than Estonian participants. So this is something that we did not expect, so I'm tempted to consider it fake news, but I guess I'll get back to it in the discussion. Okay, so then to summarize briefly, we found that the endings of resultative events triggered more looks in both groups and in both experiments. And in the verbal experiment, the Estonians attended overall more strongly to event endings than Dutch participants. And also their memory of how the events had ended was higher than the memory of the Dutch participants. So we see a strong verbal advantage for the Estonian participants. Regarding our unexpected finding, well, I can only speculate at this point, but a possible explanation might be that given the fact that we had people watch videos and perform a distractor task that involved the detection of sounds, that maybe the groups differed in how much attention they paid to the performance on the distractor task. It's very speculative, especially because the performance on this task was at ceiling for both groups. All right, so to conclude, I think the findings show, in line with what has been said yesterday, that event end states and these changes in state that objects undergo in events are central in event understanding. And we again find support for the thinking for speaking hypothesis, showing that the linguistic encoding of resultativity influences attention and memory of events. And on a general note, I would like to end by saying that investigations of understudy languages and different domains are necessary to test principles in event cognition that people assume to be universal. That's it. Thank you.
Hey, I think this is a really, really nice data set. I actually have a question about the kind of initial sort of sanity check data that you showed us right at the beginning about how people described those events. Because one thing that's really key here, right, is that, you know, we're describing these as resultative and non-resultative events, but all of those events have results, right? Like, you know, they came to an end, something's the case, right? Like in some experiments, for instance, you have tests where you're looking at whether people construe something like that as stirring an action or mixing a result, right? So do you have any information about whether your two groups of participants were similar in terms of how they construed the
Yeah.
events in terms of verb choice.
Right,
Right?
yeah. So the semantics of the verbs were actually quite similar. So we also thought that maybe perhaps this is a way for the Dutch participants to convey the difference between resultative and non-resultative. But it was actually the case that in the resultative events, people used what they call telic verbs throughout. And for non-resultative events, there were a lot of atelic verbs like stirring, measuring, or mixing. So they did not try to construe a non-resultative event as a resultative one, such as what you suggested by saying, I don't know, mixing. No, what did you say?
So is this like the stir
Stirring
mix distinction is one, right?
Yeah, versus, I don't know.
You can stir something but
preparing
not
a
mix
soup.
it, yeah.
Yeah, yeah. So this is not something that we found now, yeah.
All right, thanks.
So I got a little bit lost at one point because I thought the thinking for speaking prediction was going to be an interaction, right? Since am I right that the case alternation only occurs for the resultative events?
Yeah.
What you should have expected was better performance just for the resultative events
Yeah.
in the Estonian participants relative to the Dutch participants. Is that what you found, or did you find a main effect?
We found a main effect indeed, and
Okay.
the idea here is that also for non-resultative events, they have to apply some case marker. It's just that there's no alternation. So I think this shows that in any case, the Estonian participants are paying more attention to this phase, to event endings,
But
because
not
it is
just when
always
they
informative.
need it to make a linguistic distinction, right?
Yeah, well, they have to use some form of case marking throughout. But it is true that we started out by thinking that this effect might only show up for resultative events and maybe not for non-resultative
So
events.
it does seem like the deflationary hypothesis would be to take the same reasoning you applied to the nonverbal experiment. You said, well, I guess they just construe the task differently and apply it over here. Well, I guess it's across populations, different populations construe tasks differently. Maybe they're focusing on something else.
But I think the task demands of the verbal and the non-verbal task are very different. So I think it's a specific, maybe not problem, but weakness of the non-verbal task here because it involves a dual task. And I think if we're dealing with a production task, I don't really see how there
It seems like you want to have something in the verbal task that would, yeah.
Yeah. Okay, thanks.
Talking about episodic reflection of rapidly updated expectations, revisiting givenness.
Thank you. Right, so I'll be talking about the prosodic encoding of information structure, but I'll start by acknowledging my co-authors, Iris O. Young and Sasha Spala, and also funding from the NSF. Now, one of the fundamental distinctions in information structure is the difference between given and new information. For example, if you're looking at this display here, and if I tell you, pick up Rolex, put Rolex on number 1, then if you know your brands and so on, you'll know that Rolex is, I think, that gold crown there in the top, and that's new information in the first sentence, but in the second sentence, because I've just mentioned it, it's given information, and the new information in the second sentence is the location, the number where you should put it. And there's a lot of prior work on the prosodic cues to information structure. So we know, for example, that given information often has shorter duration than new information, has a lower intensity, given information has lower pitch than new information, and a lot of other correlates. However, there's still considerable debate regarding the extent to which speakers consider the addressee's knowledge state when encoding information structure in different linguistic dimensions. In fact, a lot of this work is done by various people in this room. So we still have some mixed results there. And on a related note, the question of how rapidly do speakers update their assumptions about what the addressee knows, this is also still something that's being debated. So in our study, we wanted to ask two main questions to add to this discussion. One is whether speakers' prior expectations about what the addressee knows, if this influences how the speakers encode givenness and newness. And secondly, whether speakers are dynamically updating their expectations about what the addressee knows based on what they discover about the addressee over the course of the conversation. So we did an interactive production study where basically participants were telling a confederate to place objects, flags or logos in our targets, in different numbered locations, And the speakers, those were our participants, they produced the sentences of interest. The addressee was a Confederate who was reacting to following the speaker's instructions. So to show you an example of a critical trial from the perspective of what the participants saw on their computer screen. Oh, and just to let you know, basically the participants thought that the addressee didn't have the labels, so they were kind of testing their knowledge of flags or logos and so on. So here's the screen I see as a speaker. I see the sentence I'm supposed to say, so I say pick up Norway. Then I see, okay, then I see on my screen what the other person did. They picked up the right flag. Then I say in my next sentence, put Norway on number 3, and I see the person correctly put the flag on number 3. On a filler trial, they were set up quite similarly in many cases, so I would say pick up Jordan. But sometimes the addressee picked up the wrong flag, so then I would simply repeat my instruction, pick up Jordan, and okay, now they got the right flag, then I would continue, put Jordan on number 4, and we can see that now they put the right flag on that location. So on critical trials, an object occurred in 2 consecutive correctly followed instructions, and the target sentence was the second sentence, put Norway on number 3. So here the object was given information, Norway had just been mentioned already, and the location was the new information. And the target objects were either flags or logos, and we also had various other kinds of trials. I can tell you more about that if you're interested. For completeness, here's an example of a logo trial, what we saw in the beginning. So we manipulated 3 things. One is the addressee's performance accuracy. Then whether the performance of the addressee actually matched what the speaker was expecting. And then we also looked at the first third, the middle third, and last third of the experiment. And let me say a few words about each of these in turn. So first, the addressee's performance accuracy. Basically, we set it up so the addressees were better at identifying objects in one category than the other. So some addressees were better at flags than logos. They made errors in only 10% of the flag trials, but 40% of the logo trials. Conversely, some other addressees were better at logos than flags. They made 10% errors on the logo trials and 40% errors on the flag trials. And crucially, these errors occurred on the filler trials. So we used the fillers to manipulate the performance accuracy. All the targets were actually correctly followed by the addressee. The second thing that we played around with was speaker expectation. And we told the participants, the speakers at the beginning, that their addressee was better at one category than the other. Some people were told that their addressee is better at flags than logos. Others were told that their addressee is better at logos than flags. And this, of course, was between speakers, between subjects. And so this means that we could manipulate whether the speaker's expectations about addressee performance matched or mismatched the actual performance that unfolded over the course of the study. So we had match contexts where the speaker is told that the addressee is better at flags than logos, and indeed, the addressee only makes errors on 10% of the flag trials and 40% of the logo trials. So here, what I see unfolding as a speaker is exactly what I expect. It's a match context. But we also had mismatch situations where, for example, a speaker is told that the addressee is better at flags than logos, but actually the addressee makes 40% errors with flags and only 10% errors with logos. So here, their performance is not what I was expecting as a speaker. And now we analyzed 3 blocks in the study, the first third, the middle third, and last third of the targets, because we expected speakers to become more aware of potential mismatches in their expectations and what the addressee was actually doing over the course of the experiment. So to summarize the design, we can think of it kind of as like a 2x2. So we have addressee performance, and I've couched this example in terms of flags. The same logic would apply to the logo trials. So the addressee can make few errors with flags or many errors with flags, and I might be expecting them to be better at flags or worse at flags. So what this means is we have 2 cells where expectations match performance. So I expect the addressee to do well, and they do well. I expect them to do poorly, and they actually do poorly in recognizing the flags. And then we had 2 cells where this mismatches. So I, as a speaker, expect the addressee to do well at picking out the flags, but they actually do poorly, or I expect them to do poorly and they actually do well. And then we looked at this in those 3 blocks across the course of the experiment. And the results, I'll be presenting them graphs like this. So on the x-axis, we have the words normalized for duration. Now on the y-axis, we took the raw F0, the pitch, and converted it into semitones. It's been shown that that matches better with people's perception of pitch. And we used a smoothing spline approach to analyze our data. What you'll see is basically shading, indicating 95% confidence intervals. And if the shading doesn't overlap, then we can assume that the 2 lines are different from each other. This type of approach is used a lot in phonetics for various types of analyses. And just to remind you, before I get to the results, that in the second sentence, the one that we're analyzing, the object noun Norway here is always given information. Always just been mentioned. So let's look at the results here for block 1, and let's first direct our attention to the solid lines. These are where the speaker expectation matches the addressee performance, and actually these solid lines start high and then they decline over the course of the utterance. Nothing too shocking there. But if we now look at the dotted lines, these are the mismatch conditions. Here we see that actually the highest F0 is on the object, even though the object is given information in all of our target sentences. And if we kind of compare the dotted and the solid, we actually see that there's higher F0 on the object in the mismatch conditions than in the match conditions. And this difference becomes much more visible as we look through the 3 blocks. In all 3 blocks, the mismatched conditions have higher F0 on the object than the match conditions, but this becomes much more visible as we look at blocks 2 and 3, where we see those lines clearly diverging from each other. So in essence, what we are seeing here is that old information, given information, which is normally unaccented, may be prosodically emphasized when speakers are surprised by the addressee's knowledge state. And note that we see this in both the mismatching good performance and mismatching bad performance cases. And this fits in with other patterns we've observed in other work where we talked about effects of epistemic surprisal, the gap between the speaker's expectations and what actually turns out to be the case in reality. And this surprisal effect is not only there on the object, it actually persists over the rest of the study as well. So if we think back to our 2 research questions, whether speakers' prior expectations influence how they encode things prosodically for the addressee, and if speakers are dynamically updating their prosody over the course of the conversation, the answer to both of these questions seems to be yes. Now, I'll also mention briefly what happens on the new information. So recall that Norway was given information, the location is a new information. And here what we see is that in blocks 2 and 3, speakers are producing that new information with a higher F0 when the addressee has good knowledge about the given information, when they're good at flags. Let me paraphrase a little bit more. Basically, speakers are producing the new information with greater prominence after they figure out that the addressee is good at picking out the flag, or good at picking out the right logo, compared to cases where they realize that the addressee turns out to be not good at flags or not good at logos. So the way we think of this is basically, after I realize, okay, you can pick out the right flag, you can pick out the right logo, I'm not worried about that, that liberates me, that frees me as a speaker to be encoding the new information with my pitch much more clearly on that final location information. So in essence, once speakers identify the most communicatively significant information, they emphasize it more relative for the addressee. So in conclusion, we think that here we're seeing that the prosodic realization of information structure is sensitive to the speaker's prior assumptions, their expectations about what the addressee knows, but also that they are dynamically updating their assumptions about the addressee over the course of the experiment. And interestingly, we see these effects of epistemic surprisal, so no matter what direction the surprisal goes in, when there's some type of gap in what you expected, we see this in the increased F0 on the given, usually de-accented information. And we're also, in the big picture, we find evidence for both speaker-oriented and addressee-oriented aspects of information structure encoding, because we see not only this epistemic surprisal type effect, but also on that new information, once you figure out what the addressee knows, it seems like you're structuring things to help out the addressee figure out the new information. So I will stop there and thank you for your attention.
We're trying to.
Hello, my name is Ariel James from the University of Illinois at Urbana-Champaign. So I just have a clarification question about the design. So as the speaker is going through, they're getting the expectation is just that their listener is either better or worse in one of the categories or the other, and then as they're going through, they're kind of alternating between the two categories, doing flags and doing logos across all of the blocks?
Yes, well, actually, they had flag trials, logo trials. We also had other kinds of trials, like tourist destination trials. So it wasn't purely flags and logos. But they would, so if we were doing it as a pair, we would be doing both flag trials, logo trials, and also these tourist destination trials.
Okay, yes.
So I'd be getting information about how good you are at both flags and logos.
Okay, yes. So I guess I was having a hard time figuring out, like, at what point the speaker should have enough information that they're better at one than the other one. But that's, I don't know, it's helping now, I suppose.
Well, I think, and that's actually a great question. And now we had the 3 blocks, and we actually had, I want to say, like 5 targets per block. I'm probably saying that wrong right now. But so we see, we see that the effect becomes clearer across the course of the experiment as people are figuring out, as they're getting more and more information. The exact, how much information exactly they would need during the first block before they start to pick things up, I think that's actually an empirical question. But that was the reason why we looked at it across the blocks, because like the last block is basically where you can be most certain that the speaker has noticed, definitely has noticed, hopefully, how good the addressee is.
Okay.
So that's why we see that divergence getting bigger.
Okay, thank you.
Thank you.
Hi, Laura Dilley, Michigan State University. I'll try to make this quick, but we need to know more about some aspects of methods in order to really interpret these results. I think the normalization method is something that's not trivial. And so to the extent that I can take this at face value for what I see, I'm wondering about your interpretation of how the listener would determine the unfolding structure of knowledge and update his or her production. In that, you seem to have focused on this particular portion of the signal, identifying the mismatch condition as higher in pitch, but don't we have to consider the moments in time immediately before that in order to convey this information, it looks like mismatch involves a rise, match involves something of a fall. How do we interpret signal cues relative to meaning?
Yes, very, very good question. Now, just to clarify, so we were talking here about the speaker, right? Not the listener, because this is being produced by the speaker.
Pardon me, the speaker responding to the listener's knowledge.
Yeah, and actually, so I have the block there on like the noun, but for example, as you see, like in block 3, that divergence between the solid and dotted lines, like this kind of surprisal, like, ooh, they're not doing what I expect, that actually persists across the remainder of the sentence too, which is not at all shocking to us, right? So if I'm talking to you and if I figure out that what you're doing is not what I was expecting, it's not surprising and it's completely compatible with our way of thinking that that will persist. And in fact, we would indeed, I'm being told I should stop talking soon, but is that getting at your question?
It starts to, thank you.
Okay, yeah, thank you.
Back here at 425.
So
all kinds of adapters. Yeah, that's the one I needed. Are you just trying out your thing as well? Yeah. Colors. Yes. Colors. All good. It's nice that they have all the adapters here.
Yeah, I
They
don't
don't
think
have
those are
yours?
going to work for me. It's
Which
okay.
one do you need? Oh, I see.
Yeah, that's a different.
Oh, you need the
Yeah.
Thunderbolt 2.
Yep.
I hate how Macs do this.
Good?
Maybe you want. Do you want this one?
You think it's different?
Well, you've got a different size hole. Yeah, yeah.
Figure it out. Thank you.
The other way up. Those things.
So which one do you need? Do you need this one or this one?
I need this one as
okay,
well.
Okay, So I will just leave it.
Why you didn't?
Okay, I got one announcement that Bill Badaker wanted me to make. There is a position open at the NSF for a program officer in cognitive neuroscience. If you or someone you know might be interested, contact Bill or look at usajobs.gov. There's a position there. So it's a cognitive neuroscience program officer available.
Hi. Original CUNY is stealing a minute of your precious time, or actually your precious time, I guess. And it's me rather than my colleague Janet Fodor, because one of us is shy and the other is not. Well, sort that out among yourselves. We draw inspiration from Dr. Seuss as follows. We know it was wet and the sun was not sunny. Nonetheless, we all had lots of fun that was funny. For this, we must thank our MIT hosts, Idan Blanc, Richard Futrell, Melissa Klein, Rachel Riskin, El Fedorenko, a truckload of backstage but unnamed helpers, and of course, Ted Gibson. Please join us in expressing our thanks.
Would anybody else like to join the long line of people making announcements before we announce the speaker? There's options. No. Okay. Well, so it's great. My great pleasure to announce our final invited speaker of the 2017 CUNY Sentence Processing Conference, Michael Dunn. Michael describes himself as an evolutionary linguist, which I think renders self-evident his participation as an invited speaker in this year's conference with our special theme of language processing and language evolution. Michael is one of the world's experts in the computational phylogenetics of human language, and he's used these techniques to make a range of contributions in a couple of core areas and then in many other areas as well. The core areas I would describe as the reconstruction of ancient language histories, number one, and number two, in understanding the typological generalizations, what typological generalizations about grammatical structure are and are not supported by evidence from languages around the world. And he's also a leader in several other areas, including putting together linguistic evidence along with archaeological and genetic evidence to advance our understanding of human origins, prehistory, and history. And he's also done work in a number of other areas, including language contact, and in fact, he began his career as in the Australian tradition, I believe, doing documentation of understudied languages, which is one of the most important enterprises in all of the study of human language, perhaps the most important enterprise today. And I personally hope that one of the outcomes of this conference will be lasting and improved connections between psycholinguistics and the kind of work that Michael does. And I hope, I think Michael will now give us a taste of what that kind of work might look like as he tells us about the natural experiment of language evolution.
Well, thank you very much for having me here, and I'm so impressed by the number of people who are still around. So I was a little worried. But okay, so I start off from the position that language change and language diversity are products of evolutionary processes. And so this means that the natural languages we see in the world today they represent a series of natural experiments, thus my title. So I want to make an argument that modern phylogenetic methods give an important complementary perspective to laboratory experimentation. So there's a big picture perspective. Such methods allow us to infer functional selective pressures on language, and also, I don't know what you call it, a little picture perspective, that phylogenetic methods can help us critically evaluate the phenomena that we think that we are studying. And I'm going to give examples of both of those things. But first off, I want to start a look at what is our natural experiment of language evolution. So we need to be clear about the distribution of linguistic diversity. What kind of natural experiments do we actually have access to? And I just have some little some statistics here. So there are roughly 7,000 languages that we know about. About half of them have some kind of minimal documentation, minimal or better documentation. But this is a rank order plot by size of language families. 70% of languages belong to the top 10 families. And the median family size is 3. So it's really skewed. So this has some ramifications for us. So, firstly, if we sample randomly, then our samples are going to massively overrepresent these few huge families. This is something which in anthropology and sometimes in linguistics is called Galton's problem. So the problem of statistical non-independence of observations of evolved phenomena, things that so... the usual solution to Galton's problem within linguistics is to try to find a sample of languages which is like notionally independent. This means taking one language from each family, trying to select languages which are geographically distant from each other. When this is done well, this really limits our language sample down to around 100 languages. There's 100 languages we can use as a database to understand human language, which is, to me, seems somewhat absurd. It also, and there are problems even with this sample too. So it means necessarily it heavily overrepresents languages from these tiny language families, which may be subject to different kinds of social processes, which may have systematic effects on language structure. There's all kinds of possible problems there. So I then wish to put forward the evolutionary phylogenetic approach instead. So the phylogenetic methods, a family of methods adopted from evolutionary biology. These methods, with these methods, we fit an explicit model of evolutionary change to observational data. So this usually has two components. They're actually the two major things that I've been working on. These are two that they are logically and sometimes technically separate. There's the enterprise of modeling how languages are related to one another, so making language family trees, and then the other part of this, which is the enterprise of studying modeling of the particular phenomenon that you're interested in over that known genealogy or that inferred genealogy. So the non-independence of our observations, Galton's problem, is solved here by explicitly modeling the dependencies between our observational data. So we're looking at variation in some structural feature of language. If we have a model of how those languages are related to each other, we can build that into our model, trying to understand that feature. And to me, like as a sometime field linguist, this spares us from having to discard 6,900 of the languages that we of the world, or the 3,400 that we know something about. It lets us use every one of these precious, rare observations of this great natural experiment of language evolution. So, okay. So, just a few words on some of the methods that are available within the family of phylogenetic methods. Before I get into giving examples of some actual analysis. So first off, we have the problem of establishing these genealogies. So And I call this item 0 because it's the thing that we do before we really start doing the thing that we're interested in. So I won't say anything much about this beyond the fact that this is, we usually, within phylogenetics, infer family trees by modelling the history of cognate lexicon. So, yeah, and usually by using Bayesian phylogenetic methods these days. I don't know if this is the right thing to say, but in many cases the only thing, so this is like establishing a classification of languages, in many cases the only thing that makes this not boring is how angry it makes historical linguists. But, I hope this is, I'm probably the most historical linguist here, so I hope it's an okay thing to say. So, no, someone else. Okay, but so, yes, but then, what I'm really interested in, what I want to try to interest you in, are a family of methods called phylogenetic comparative methods. This is an unfortunate terminology because, of course, in linguistics we already have a comparative method, but so I always try to say phylogenetic comparative methods. It's a plural, there's many, many of them. So I'm going to list some of them. So first, there are a set of different methods which investigate the properties of language family trees. And Russell Gray, Fiona Jordan in the year 2000 published a paper which I think really set this whole enterprise going. And in their first paper, they tested competing hypotheses about the migration path of the Austronesian-speaking peoples. And so the method they use tested the two proposed migration paths against the structure of the family tree that they could infer from lexical data, and show that the branching pattern of the genealogical tree was consistent with one geographic progression and inconsistent with another. So that's that's kind of like a textbook case of a phylogenetic comparative method. And then later, as well, particularly as the biologists have become ever more sophisticated, we have got access to methods that allow us to infer calendrical dates, so we can actually try to date aspects of language histories. So this is a family tree with big bars showing our 95% most credible, most confident prediction about when particular dates, when particular branching events happened within the history of this language family, and also not only dates but also places. And so even more recent methods allow us to make inferences about the geographic location of events within the history of a family tree. So there are also methods which study the mode of evolution. An example of this is the debate about punctual versus gradual evolution. Mark Pagel proposed some ways to investigate whether the evolution of a language family is happening gradually, or whether there are bursts of evolution. And this is done with, so if you make a model of a language family evolution where branch length is reflecting the amount of change, then the right-hand tree labeled gradual there is this is a tree where we have the same amount of change has happened on every branch. The left-hand tree, the amount of change on a branch measured from the root to the tip is proportional to the number of nodes, the number of splitting events that have happened within that history. And so a punctual kind of history would, if you graph the number of nodes against the root to tip distances, we would get an upward line, and if it was gradual evolution, you would have a flat line. And then, and here's some actual measurements taken from actual language showing that punctuation seems to be a factor in language evolution. So, but then what I'm really going to talk about then are methods which investigate the evolution of features of language. So, and I'll race through this quickly because I have some actual examples, but here we have a method of ancestral state reconstruction which lets us propose, these are all little pie charts, but they let us infer the probability of a particular feature having a particular state at each point in history. So in this particular study here, again by Fiona Jordan, they are looking at matrilocal versus patrilocal residence, so actually an anthropological feature rather than a linguistic feature, but one which is thought to be carried along with language. You know, language is a cultural marker, and these other cultural phenomena as well. So, and then another technique, which I'll also show you an example of, is model inference, where we can study the particular patterns of change between different states of a feature. And so here, once again, another anthropological example, we have the evolution of political complexity, once again within the Austronesian languages. So we have the variation between acephalous, acephalous societies, simple chieftains, complex chieftains, and complex states. And on the tree, we have all the observed states in the anthropological present, and the inferred ancestral state at every node below there. So that's the ancestral state reconstruction. And then here we have a graph of the transition probability between these states. It's the most likely transition probabilities to explain this particular pattern, and it's quite an interesting model. So the weight of the arrows, of course, is representing the magnitude of the probability. It's a model where political complexity can change incrementally, but also it allows big steps downwards, but doesn't allow big steps upwards. Yes, I probably should have a Trump joke in there as well, but I don't. And then the final technique that I want to talk about today is methods which test evolutionary dependency. So these are methods which test for the coupling of features within an evolutionary history. Here, this is a subset of some of my own work showing just on a tree Indo-European languages which have verb-object or object-verb order as the first, the little circle next to each name, and then on the left, and then on the right, whether the language has prepositions or postpositions. And you can see that most, but by far, almost not all of these languages either have blue-blue or red-red, which means that they're either OV languages with postpositions or VO languages with prepositions, like a well-known typological pattern. But it's also a pattern, if you look at the structure of the family tree, there must have been changes between these pairs of states multiple times within the tree. So it seems like when one feature is changing, another feature is changing. So what we're looking for is, a pattern perhaps like this, where this is the same mirror plot of a family tree. So state changes in one feature here, just X, mirrored by state changes in another feature. Okay, so that's racing through some of the methods that we have available to us. Now I want to talk through two case studies. The first one, well, it's a paper I've just published with some historical linguist colleagues. And in this paper, we're testing a hypothesis about the evolution of, or about argument structure change in the Germanic language family. So this is not a really big question about human language, but it's within that community. It's an important question. So the phenomenon that we're looking at is the diversity of different non-nominative subject constructions. So here's an example from modern Icelandic, which I won't read out, but we have the subject of this clause, I need an interpreter, is in the accusative. If you want to, like a slight sense of this, this line, the well-known line from Hamlet, methinks, that's actually a fossilized form of the same construction, where think is a verb that in Old English had a non-nominative subject. Okay, and so there is, so this, these kind of constructions have dropped out of many, but not all, modern Germanic languages. And the process by which they have dropped out is a process which they rather charmingly call dative sickness. So the dative sickness, well, there's usually dative subjects turning into nominative subjects, but it also, the wider phenomenon includes accusative subjects also disappearing. And accusative subjects, according to the historical linguist's account, either turn into dative subjects as a way station on the way to turning into nominative subjects, or they go directly to nominative subjects. But dative subjects never become accusative. So they're basically proposing a hierarchy there in that process. So okay, the recipe then for a phylogenetic comparative method is this is kind of a standard analysis. So we have a hypothesis about the genealogical relatedness of the languages that we're interested in. We have some kind of model of how the feature of interest changes along that genealogy. So this model is simply well, it's the simplest, least constrained model where we simply have nominative subjects, accusative subjects, and dative subjects, and transition probabilities between all of them. And then a set of observations. And so our set of observations is 12 cognate sets, 12 predicates in the Germanic languages which have dative subjects in some of the languages which historically had a dative or accusative subject, which are known to be subject to this dative sickness process. And so what I want to show here then is a model testing analysis where we compare an unconstrained model to various constrained models. So the dative sickness model proper, which as I explained it before, is a process where dative subjects can turn into nominative subjects and accusative subjects can turn into either datives or nominatives. And then we and a couple of other, here's some other like straw man models, which are other ways that these things could change. So these are just 4 representative models. In fact, there are 58 possible combinations of constraints. When we fit all these different models to that phylogeny, then the unconstrained model, of course, fits the best, but the dative sickness model fits very well compared to all the other 58. When we look at the inferred transition probability on the constrained model, it's completely implausible. The ancestral state reconstructions are completely implausible. So we're not, instead I want to just look at the dative sickness model itself. When we look at the dative sickness model and its, how it fits the data, the ancestral state reconstructions to that model are 11 out of 12 of them are completely correct, and the 12th is very, very close. So simply then, the phylogenetic modelling of this process confirms the prose model that historical linguists have proposed for this process. So I would have to show you all the data, but basically no other high likelihood model makes an accurate reconstruction. So that this sort of confirms that the dative sickness model is the best model fitting that data. But okay, but moving on then, because I only have 10 minutes, so maybe more interestingly, here's a paper by Ted and others from a couple of years ago in which they propose a very sensible hypothesis explaining how the alternations between subject-object-verb order and subject-verb-object order explains this communicative function terms. So with a preference for the verb medial construction triggered by contexts where a noisy channel would render SOV to be potentially ambiguous. I don't have anything to say about that per se, but apart from the, so most of the paper's devoted to discussion of a gesture production task, but the authors also made some typological predictions. So in particular, they made some predictions about constituent order and explicit case marking of core arguments. So in particular, they predict a relatively high frequency of case marking in subject-object-verb languages, and that this would be stable. They predict that subject-object-verb languages without case will be unstable, and they point out some evidence to support this, that 72% of subject-object-verb languages are case marked, whereas only 14% of subject-verb-object is the case marked. So I'll address the last point first, why we need to think about this. So this is a question of skews in the observed frequencies. So just because observed frequencies are highly skewed, we can't assume it's meaningful. So looking at the same World Atlas of Language Structures database that this data came from, we have the same skew in languages with the locative type of comparative construction. So this is language where to say the elephant is bigger than the horse, you would say the horse from the elephant is big. And this would be compared to the surpass type, where you would say the elephant is big defeats the horse, something like that. Another such feature is the paralinguistic use of clicks in an effective function, so positive or negative effect, compared to languages which use clicks for a yes or a no. So 20% of SOV languages have paralinguistic clicks in the meaning positive or negative effect, whereas 71% of SVO languages do. So something clearly not anything to do with information. And finally, this is not quite such a big skew, but only 7% of subject-object-verb languages have their word for tea a cognate of min nan te, whereas 50% of SVO languages do. The other type is the Sinitic cha, which is chai lattes and whatnot. So we need to think about these skews. We can't just because it's 70-20, that doesn't mean there's a phenomenon. We do need to look at them. Like, there is a phenomenon. I'm not going to say that you've got it wrong, but it's something that needs to be looked at. So to remind you then, so we're asking a question about correlated evolution, about this evolutionary trade-off between constituent order and case marking, and from the description in the text, I suppose we're looking for something a bit like this. So on the left, it's a replicated burst pattern. So on the left, we have changes between languages having case and losing case, leading to languages becoming SVO that used to be SOV. That's just what it says in the text. Now here's a full set of language data from the World Atlas of Language Structures, a family tree from Glottolog, made into, it's a bit squeezed up here, but basically made into a super tree where we have all the family trees all joined together by very, very long branches, long enough that change should saturate on those branches and just reflect the base frequencies, and not contribute to the phylogenetic structure. And what we're doing then is a model test where we test an independent model of change. So a model test where we simply infer rates of change between SOV and SVO and between having core case marking and no core case marking, and compare this to a dependent model of change where we treat those as combined features. So, so we have the two, if we're going to be Greenberging about it, sort of harmonic cases, well, the SOV case languages and the SVO non-case languages, and then the other kinds here, and so we fit that model to the data as well. So we fit both of these models, and we look at which model fits better, which model better describes the process that's going on. And so the answer is the dependent model indeed fits the data better, which is of course what you'd hope to see. But there are maybe a few interesting things to say about it. So these are the inferred transition probabilities between these states. So what can we say about these things? So firstly, indeed, subject, object, verb, and having case is a stable optimum, that we have high probability of getting into that state and low probability of getting out of it. Likewise, subject, object, verb, and no case is unstable. There's a high probability of getting out of that state and low probability of getting into it. So the hypothesis that was made in the paper, and I don't know how important this is to you, but that subject, object, verb languages without cases would become SVO is not supported by this data. This does not seem to be the pattern of historical change. Instead, what we have is when we have these unstable SOV non-case languages, they tend to gain case. And then as what we have, like a bonus observation here is there is a strong tendency for SVO case languages to lose it. So then in general then we can say that the natural experiment of language evolution shows that case changes to harmonize with constituent order rather than vice versa. And this invites a theoretical question, which is, can we think of a causal mechanism, and can we devise a lab experiment to test it? And that is the end of my talk.
We have about 10 minutes for questions, so let's try to keep alternating tenure, non-tenure if we can.
Or if we can't, we won't. There's something I've kind of always wondered about, right? It seems like with the SOV SVO, there's always the connection between post and prepositions,
Mm-hmm.
and then there's a connection with case. And then when I played around with walls, right, there's also the connection with post versus preposition and whether you have case, with postpositions more often resulting in case. And so I'm wondering if that might be the reason for the case going to synchronize with the word order that you were saying. That for some reason there's something that allows postpositions to more naturally become case markers, maybe based on how we process information. Do you know any way to test that, or have you ever looked at that?
It's a great idea. I certainly can't
You can
tell
make
you
a
whether it's right or
dependent
not.
model
It's a
versus
brilliant idea.
non-dependent
Yeah,
model for that, right?
that's definitely the sort of thing that we should be looking at. Yes. Yeah,
thanks.
That's great.
So I have a data question, actually. It's really a modeling question. It's kind of a data question, which is, as you said in the beginning, there's only half of the languages around we have non-trivial amounts of information about. We could be even more pessimistic and say that there's one language that we have non-trivial amounts of data about, and we still don't understand that one very well. Which makes me wonder not why we should, give up on this whole project until we have lots more data. Obviously, we shouldn't do that. My question is there a way to take into the modeling, in the modeling, take into account the amount of certainty we have about a language? Like, for instance, you could do something really dumb, just like number of publications about that language, in order to have, say, less confidence in your data for some languages relative to the others.
So that's always been possible in principle, but actually since this particular version 3 of Mark Pagel's software, he's actually implemented uncertainty on observations as well. So yeah, actually, as of a couple of weeks ago, it can be done. And so certainly nobody's done it yet in language data, but I think it could be done. Like, I think you don't need too much precision in your, probably, good and bad, or good and okay and bad would probably be a fine-grained classification enough to be able to work with. So yeah, that's something that we will be doing in future.
Awesome, thanks.
Yeah.
Thank you so much for providing an exemplar of what I was hoping we would see of a psycholinguistic prediction that emerged from this community that could be tested using your methods. Thank you so much. And now I hope we all have license to generate typological predictions from our psycholinguistic work and give you a lot more work to do.
That would be lovely.
It seems like a really wonderful,
Well,
productive, positive way forward. I have a technical question
Yeah.
regarding how you carried out the study testing Ted and colleagues' prediction. Could you go back to that slide of the dependent model? Yeah, perfect. So my memory is that in earlier work that you did, like say in your 2011 paper, the dependent model, the way dependent model was set up was not. So here, at least presentationally, it looks like you're estimating, you're saying, oh, there are these probabilities of actually changing between states, where states are conjunctions of Boolean features. Whereas my memory is that the dependent models that you used back in 2011 there were models that said each feature has a probability, has a transition, a probability of changing that is conditioned on the value of the other feature. And so you didn't have the possibility of simultaneous change of both features because it was a continuous time underlying model. Is that correct, or am I?
I'm not quite sure I follow you. This is.
So I guess like is the idea of changing? Should we interpret moving from like? I need to see. Sorry, I'm sorry. Never mind. Just forget what I said. I misread. Misread the graph. No. Never mind.
I was right not to pretend I understood you in that case.
Cancel my question.
Thank you.
From non-tenured people, not tenured people. Bad idea. Get too many tenured questions.
Hi, my name is Kathy. I'm from Northeastern University. I'm just curious, because this methods are really exciting to me. I don't know anything about them, but how accessible are they to people working in psycholinguistics? Like if I wanted to go and make an experiment where I tested, say, some kind of constraint optimality theory, and I was interested in looking at all the history of languages, like what kinds of data are coded in these databases? Is there phonological data? Could you use it for other purposes?
So it's certainly a weak point of these methods that they require quite a lot of quite a lot of cross-linguistic data. So if you're trying to estimate the rates of changes between major typological features of languages, you need enough instances of those changes to be able to make an estimate of the rate. So this super tree method with glomming all the language family trees in together is something which we've only started doing recently, and probably has some wrinkles that need to be ironed out. And so then it's just a question of, can you get hold of the sort of data that you want to analyze? So we have the, this is not going to let me jump there in one go. We have the World Atlas of Language Structures, which some people have talked about already. We have Glottolog, and which provides fairly uncontroversial genealogical trees. There's Foible, a big database of phonological data.
But theoretically, something like this, these methods of using phylogeny as a natural experiment to test constraints, I think that's a really intriguing idea. And I think hopefully more people will get involved in this kind of work. But
I hope so too.
Thank you.
Cheers, thank you.
Hi, I'm Pooja. I am from the linguistics department at Harvard. My question, could you go back to the previous slide, please?
Yeah.
My question is about the history of English. And so we know that English at a previous point used to be SOV and have case marking.
Yeah.
And there's been, as far as I understand, a debate about what led to its current state, whether it was a move to SVO that led to the loss of case, or a loss of case that led to the move from SOV to SVO. And I'm wondering whether your model actually, have you thought about the history of English and how that relates to this model?
I haven't thought about the history of English, no, and I'm not sure if history, like these are broad statistical patterns. I'm not sure if these methods, whether their strength is really to be investigating individual languages.
Sure.
Just looking at this, just looking at this. So we're talking about how you get from here to here, yeah.
Yes.
And so do we take the top road or the bottom road?
Yes. It seems impossible right now.
It's not obvious. It's not obvious what the best way to do it is.
Right.
In fact. Yeah. It is a low probability step.
So, I mean,
either way.
I imagine it's not just English, and historically that's happened quite a bit. So you would want a story for, the natural way to go from SOV
If you wanted
to
to force me to make a bet, I'd say it took the top road because because to get to here, then you've got the low probability change, and then it's almost inevitable to follow the rest of the way. Whereas the other way,
I tend to agree with you, and I think one other characteristic that correlates with both of this is the sort of flexibility of word order, right?
Yeah.
So
And
it would be interesting to see how that also maps onto this.
Yeah, very short, but very, I don't know, worrying. Like, I've been worrying a lot about those, the half of the languages about which we know nothing, and also the languages that keep dying. And I just want to know, as somebody who has thought about all sorts of languages for many years, maybe it's a question for Caius as well, for later discussion over drinks, but to what extent have you learned something about some properties of languages that have recently become documented that we know very little about, that have changed in pretty fundamental ways how you think about language in general?
Well, in the well-trodden ground of constituent order, Greenberg's typological generalizations were based on the information that he had available to him at the time, and since he made his various absolute universal statements, people have come up with exceptions to, I think, probably every single one of them. To me, that's not interesting because we're talking about frequencies. But to the fact that every low frequency type is actually there somewhere means that we can model these things better now than we would have been able to before. So we should worry, yeah.
Okay, our next speaker is Liz Schotter. She's going to tell us about parafoveal and foveal information in reading, saccade programming versus comprehension.
Thank you. So I want to talk a little bit about a paradox that has kind of been annoying psycholinguists for a while, and that is that when you look at the time course of word recognition during reading, you get different estimates for when that happens depending on which of the methodologies you use. So in general, the amount of time that we spend looking directly at a word before we move on during natural reading with eye movements, the estimate's around 200 to 250 milliseconds. When you compare that to the estimates of when people recognize that a word makes sense in context, that happens around 400 milliseconds, according from ERPs. And people have proposed that maybe it's the ability to get information from upcoming words during reading that might solve this problem. But then if you look at co-registration, so measuring ERPs while people are reading naturally, you still get very similar estimates for the time course. So it's still been a bit of a paradox. And then there are also, we have our own debates about exactly what parafoveal information is being used for and how that leads to preview benefit. So today I want to talk about both of these things, mostly focusing on preview benefit, but I'll get back to this paradox about the time course later on. So what I mean by preview benefit, for those of you who aren't familiar with it, it's basically the ability to get information from a word before you even look at it. And the way that we study this is by choosing a particular word in the sentence. We track eye movements while people are reading. And we set an invisible boundary, invisible to the subject, we know where it is, and we replace that word with some other stimulus, we call it the preview, while people are reading parts of the sentence prior to it. So the only view they can get of that word before they look at it is this preview stimulus. Once they move their eyes to directly fixate it, we change that word to something that we call the target. And then we measure how long people spend looking at that exact same target word based on whatever different previews we could give to the person. And the general finding from the literature is that people are fastest if they have access to the word itself, the identical preview, the target itself, than if they have some sort of different unrelated word, that's this unrelated baseline, or if they had a string of X's or something. And then if the word is related in some sort of way, then people are somewhat intermediately fast in reading the word. That's the general finding from 40 years of research. Recently, though, there's some evidence that suggests that it might not actually be the relationship between the preview and target that actually matters for preview benefit. And this is work that came kind of as a zeitgeist between Vildre and Andrews and myself. And I'm just going to show you my data, but theirs is basically identical. If you look at previews that are not related in any way to the target stimulus, but are plausible in the sentence context on their own, are an equally good stimulus, then you find that there is preview benefit relative to some other unrelated stimulus that on its own is not a good stimulus in the sentence context. So what this suggests is that it might not be that you are trying to linguistically integrate these two pieces of information. It might be something about the preview itself that's contributing to some sort of processing benefit, and that might be independent from whatever processing or whatever information you get from the target once you land there. So one thing that I want to highlight is that while this conceptualization of this is relatively new, we can explain this within existing models of eye movement control in reading. So this is already explainable, and I don't actually have to change anything about these models of reading. And what I'm going to talk about, it's going to look a lot like Easy Reader, but it's basically the same assumptions of Easy Reader and Swift. This is something that's shared between them. So this is just general principles of ocular motor control in reading. And that is, if we think about what you need to do when you read, you need to recognize a word and plan an eye movement away from that word. If we waited until word recognition was complete before we started planning eye movements, then how long it would take to look at that word before we moved on would be obscenely long compared to the empirical measures or estimates that we have of how long you fixate a word. So the way these models solve that problem is they actually start saccade planning before complete word recognition. So this means that we don't actually know what a word is completely before we start to plan our eye movement away from it. And that helps in giving us some savings in terms of time. But moreover, since we then complete word recognition at the same time that we're planning an eye movement away from a word, if we have any time left over, we then can shift attention to the upcoming word and start word identification on that next word before we get there. And this is how we get preview benefit. That also leads to an even more savings in time. And now we're well within the estimates of the empirical data on how long people spend looking at words. So this leads to different possibilities of, the other thing I forgot to mention is that saccade planning comes in 2 stages. One stage you can cancel the current saccade plan and make a different one, and one you can't, you're committed to making that saccade. And that's important because this leads to 3 different possible situations in which you could fixate or not the upcoming word. So if you recognize that you want to plan an eye movement away from the upcoming word while the plan to fixate that word is cancelable, you cancel it and you skip over the word. If by the time you move your eyes to that word, you haven't yet reached that completion of the first stage of word identification, then you need to actually get direct information, foveal information from that word before you can start planning an eye movement away from it. And so your fixation on it is going to be relatively long. If, however, and this is a really interesting case, you recognize that you want to start planning an eye movement away from the next word, but you are in a eye movement programming stage toward that word that is not cancelable, you are committed to fixating it. We call this a forced fixation. This is actually something that was proposed by Bob Morrison in 1984, so that's not new either, but I think that it's kind of gotten forgotten for a little while. So what that means then is if you pre-plan, what you can do is pre-plan the next saccade away from that word, which means once you land on it, that intervening fixation is going to be relatively short. And this is how we get preview benefit. The interesting thing is that these different cases then, depending on how they're distributed across the trials that you have, can lead to some interesting and sometimes surprising effects when you think about this idea that we're integrating preview information and target information. And it can actually predict the opposite sometimes. So I want to tell you about a recently published study in which we did this display change paradigm. We had a preview that was either identical to or different from, completely unrelated, except that it was also plausible, equally plausible in the sentence context. We found the general finding that you're faster to process the word if you have a valid identical preview than if you have some different preview. But critically, we also used other conditions in which we switched those 2 words. And the critical difference between these 2 words is even though they're both equally plausible in the sentence, one of them is higher frequency than the other. And so if it's higher frequency, it should be easier to recognize or easier to identify. If it's easier to identify, then you should complete that first word identification stage on it earlier, and you might be more likely to either skip over it. In most of our studies, the skipping rates are the same, but crucially, if you don't skip it, you might be more likely to have these short fixations. So what you would predict and what we actually find is a reversed preview benefit in this case, where the different preview is easier to process than the identical preview. This cannot be explained within a linguistic integration account. And we're saying that this is caused by forced fixations. And if you think this is crazy, which many people do, I've replicated, I'm showing you the original 2 replications. I also have another data set where we replicated again. So I'm very confident that this is a real phenomenon. It's important to make sure that your skipping rates don't differ between the 2, because skipping can steal from forced fixations. But what I want to talk about now is what the linguistic consequence of this ocular motor benefit is. So we know that people sometimes misrepresent, misidentify, or get confused about the words that they had read in the sentence. And if they do, then they go back and they make a regression back to reread those words. So we're going to take advantage of this fact and use that as a way to study what people thought they had read from the sentence. The other thing is we know that in these, and these are non-display change experiments, but we also know that in display change experiments, sometimes people make regressions back because they notice the display change or they have these two different representations. So we'll handle that as well. So we took the sentences from the original study, and we have a critical region at the end that makes one or both of those words implausible. If that's the case, they should make a regression out of that region if that's the word they had encoded. We also had a buffer region so that we could determine if any regressions were due to noticing the display change. So I'm going to go through this relatively quickly, but I think it's pretty clear. So regressions out of the target region for the both plausible, target implausible, preview implausible, both implausible. The plausibility doesn't matter because both words are plausible here. What does matter is that if the word is, if the preview word was high frequency, people just didn't regress out of it. This is because they had pre-planned that fixation forward, and that's what they were doing, regardless of whether there was a display change. If the preview was low frequency, they hadn't pre-planned that saccade forward, and then they start to notice whether there was a display change or not and make a regression. For the buffer region, we get essentially the same thing, but now we see that effect of noticing the display change for the high frequency preview. So because they had committed to moving forward, they couldn't notice or respond to the fact that the display had changed until the spillover region, the next region. Critically, in the critical region, their regressions out were based on the implausibility of the target word, not of the preview word. And we didn't really see any effects of the display change or the frequency of the preview there. And if you want to see how this emerges across, so then we're saying, okay, we have evidence for forced fixations, people detecting display changes, and people encoding the foveal target. And this emerges over the sentence, so that this is basically just showing you a cumulative plot of that. But display change detection happens in the buffer region, but really what people are encoding from these words is what they directly see. So what that means is that you have two sources of information that you use for different things. You plan eye movements, you maintain reading speed using parafoveal information, but what you really get out of the text is what you directly see from it. Thank you.
So in these, Trevor Brothers, UC Davis, in these display change paradigms, you talk about kind of consciously noticing display changes afterwards.
These people don't. These are not people that consciously notice them.
So you have those regressions in the following region.
Right.
Do you think that's kind of like some subtle unconscious processing difficulty that's driving those? Or?
Yeah, we exclude people who report noticing a lot of display changes, and it's not a lot of people in these studies. But these are all people who basically, they say, oh, I might see a flicker or something like that. So I don't think that they're consciously aware of these display changes, but I think that the reading system has some idea that I thought I had read one thing and now I have this other representation where these two words next to each other, like they generally don't think that words are changing on them.
And so it seems like the representations aren't really lingering later into the sentence. Do you think there's some kind of active suppression mechanism going on, or resolving that ambiguity between the two words?
So I think that it's that because the eye movement was planned not based on full recognition, that I don't know how strong of a representation of the preview they actually have. It might be used just to be like, do I think this will be recognizable? And then that's based on a poor acuity You know, like parafoveal information is not as clear as foveal information. So I think that if they have both of those representations, they're more likely to discount the preview information just because they know that it's not as high fidelity.
Gotcha. Thanks.
No, it's not quick. Thanks.
All right, let's thank our speaker.
Therese. Doesn't matter. Okay.
Ready? Yeah. Okay. Our next speaker is Therese Gruter, who will tell us about event structure modulates anticipatory looks to potential next reference.
Right. So when we listen to speech, process discourse, we create mental models of the events that are being talked about. And we know that these mental models that we create and incrementally update influence our expectations about how a discourse will continue, and more specifically about who will be mentioned next. So, for example, you hear, Winnie gave Nancy some chocolates. Your situation model might look something like this. Now, if I asked you to continue this discourse, starting with the pronoun she, I'm sure you could easily come up with continuations in which she refers back to Winnie and others in which she refers back to Nancy. But we also know that there are a bunch of well-studied cues that drive our biases when it comes to the interpretation of ambiguous pronouns like these. For example, pronouns like to take antecedents that are subjects, that are in parallel grammatical roles, that were first mentioned, and so on. Now, in this particular case, just about all of these, most of these biases should drive us towards a subject interpretation, one in which she refers back to Winnie. However, previous research looking at examples, contexts like these, namely transfer of possession events described in the past tense. Previous research going back to Stevenson and colleagues and subsequent work by Jennifer Arnold has found that we actually get a remarkably high proportion of goal continuations. There'll be cases where she refers back to Nancy. And one explanation for this has been that this is driven by an event structure bias, more specifically a bias to attend to the end state of an event, something that's been mentioned in several talks over the past couple of days. So in the case of transfer of possession events, the end state is when the goal has received the theme. Nancy now has the chocolate. And that puts a focus on Nancy and may create an expectation to hear more about Nancy rather than Winnie. Now, my co-author, Hannah Rodian, her collaborators a few years ago put this hypothesis to the test, saying, well, if it's really an end-state bias, if we take the bias, we tend to focus away from the end state, then goal continuations should decrease. Well, how do you take the focus away from the end state? You make the event incomplete. How do you make an event incomplete? English offers you a convenient grammatical means to do that. You change verbal aspect from perfective to imperfective. Winnie was giving Nancy some chocolates. Now your situation model might look more like this. And a question that Rodi and colleagues asked is, well, does that change and make a difference to your biases for interpreting the pronoun? And it turns out it does. In a written continuation task, they found a significant decrease in goal continuations, that's your black bars, following imperfective transfer of possession events compared to perfective ones. And this is, in fact, an effect that has been replicated across multiple labs. The most recent replication I've seen was 2 days ago in a poster by Anna Besserman and Elsie Kaiser. It has also been replicated in other languages that use verbal aspect to mark event completion, such as Japanese, and in our lab we replicated it in Korean. The best explanation for this seems to be in terms of discourse level expectations, whereby verbal aspect influences the situation model that we create, which in turn affects our expectations about who will be mentioned next. Now, if this is really an expectation-driven effect, then we should really be able to capture these biases before a pronoun or any referential expression comes in. Right? And there is some evidence in support of this from an ERP study by Ferretti and colleagues. They presented their participants with sentence pairs like this, in which they manipulated two things: aspect in the first sentence and pronoun reference through gender in the second. And what they were looking for were effects of surprisal at the pronoun, surprisal as an indication of potentially disconfirmed expectations. And to make a long story short, they report that they found the strongest evidence of surprisal at the pronoun when that pronoun followed a perfective sentence and referred back to the source. Now, perfective is exactly when you would have end state focus, an expectation for goal, so source does indeed violate that expectation. So this aligns nicely with the previous work. But the effect is still only found at the pronoun itself, right? So in our study, we just wanted to push this one little step further and see, can we capture this bias before the pronoun comes in? And so we want to ask here, does aspect affect reference before a referential expression is encountered? And today I'm going to show you the results of 2 visual world experiments, one not quite finished yet, that suggest that the answer to this question is in fact yes. So in experiment 1, our goal was to assess referential biases before an anaphor is encountered, and to this end, we adapted the design from the Ferretti et al. ERP study to the visual world. Using very similar sentence pairs, manipulated the same 2 things, aspect in the first sentence, reference through gender in the second. Our visual scenes contain the source, the goal, and the theme, with their respective location in the scene, counterbalance between items. And here's an example of a trial. We get some preview of the scene. The first sentence, followed by a pause, a substantial pause of 2.5 seconds, followed by the second sentence, shortly after the offset of which the visual scene changed, the pictures were replaced by boxes, then a question, which in the experimental items was always about the identity of the subject of the second sentence. Participants clicked on the box that corresponded to where the answer to the question used to be. Now I can tell you mouse click accuracy was at ceiling. We added this last component of the trial just to keep participants engaged. What we really care about is what's happening in this silence region between the first and the second sentence. Are we seeing differential looks to the goal versus the source? Is that modulated by aspect? So to start with, I'm going to show you just collapsing over all our manipulations, just people's eye gaze behavior over the entire trial. And you can see in the first sentence, sanity check, yes, they look at the things that are being mentioned in the order in which they're being mentioned. And then in the second sentence, this graph is not particularly useful because half the time reference was to the source, and they looked at the source, and half the time was to the goal, and they looked at the goal, so this is canceling each other out. What is of interest to us is what's happening in that middle region. And what we're seeing is that roughly in the second half of the silence region, what seems to be emerging is a slight bias to look at the goal versus the source. And what is of interest to us, remember this is collapsing over all manipulations, is this bias modulated by aspect at all? So here we're zooming in on the silence region, and right now I'm only showing you looks to the source. But as predicted, we are in that time window. We're getting more looks to the source following imperfective than perfective. And if we look at looks to the goal, this is exactly flipped. So what this suggests is that this goal bias really comes from the perfective transfer of possession sentences and pretty much goes away in the imperfective ones. Now, one question that we are still struggling with and very much welcome feedback on is what are the appropriate stats to do on something like this? Noting that this is an effect that is not tightly coupled to a particular acoustic event. We haven't solved the problem yet, so for now we're trying to be as conservative as we can and look at the largest potentially relevant window, which is essentially the entire silence region. We do allow for some wrap-up of the first sentence and looks to the last mentioned entity, the theme, to come off. So we start 500 milliseconds into the silence and extend all the way until 200 milliseconds after the onset of the second sentence. Within this window, we look at the likelihood of looks to the goal versus looks to the source. And indeed, our model suggests that we do get a main effect of aspect here. So the results from experiment 1 suggest that yes, aspect affects reference before a referential expression is encountered. Now, in experiment 2, we wanted to push this a little bit further and see is this still true in somewhat richer discourse contexts. So experiment 2 Same procedure, same method, now slightly richer items. So now each experimental item starts with a sentence introducing 3 human referents of the same gender. 2 of them are then re-mentioned in the second sentence, which contains the same critical aspect, manipulation. And the visual scene now contains these 3 human referents, the theme, and an unmentioned potential theme. In addition to aspect, we also manipulated contrastive prosody. The second participants heard the second sentence in 3 different conditions, either with broad focus intonation, as they did in experiment 1, or with contrastive prosody on the source, or with contrastive prosody on the goal. Now, I'm not going to be able to tell you about the effects of this manipulation today, in part because we're not quite done collecting data in this experiment. Our sample is somewhat unbalanced at the moment. I will be happy to talk about this, and actually by we, I really mean Amy Schaefer. Please direct any questions about this to Amy. So for now, I'm going to begin again by showing you the same overview, collapsing overall manipulations, same sanity check in the first sentence. And in the silence region, we see again, roughly in the second half, an overall bias for looks to the goal versus looks to the source emerge. Is this modulated by aspect? And this is our preliminary data set, and again, we see the same general picture. The effect is bigger following perfective transfer of possession events and is at least attenuated following imperfective aspect. No stats on this yet, since this is not the final data set. In summary, these results suggest that verbal aspect creates expectations about next mention before a referential expression is encountered. I think it's fair to say that the effect is modest, but it does appear to be replicable in different discourse contexts. More generally, this supports explanations of reference processing in terms of incremental updates to situation models and resulting expectations. That is a proactive, forward-looking view of reference processing that goes beyond mere integration once you encounter a referential expression. Our next steps in this project are obviously to look at contrastive prosody in experiment 2. And then a broader goal of our broader project is to probe the generalizability of effects like this beyond the exotic minority group of monolingual native speakers of English. We have already presented preliminary findings from second language learners in experiment 1, and we're currently collecting such data in experiment 2. And finally, we're playing with effects of task demands, in particular, whether it makes a difference if participants just have to listen to the continuations, as they did in experiments 1 and 2, or whether they actually have to produce those continuations themselves, as they did in the story continuation experiments. So hopefully more on this to come in the near future. For now, thank you very much.
Hi, Jeff Runner, University of Rochester. That was really cool. I wasn't, in the first eye tracking experiment, what happened when they got to the pronoun? What did they start looking at? Were some of the conditions going against the expectations? I wasn't sure if it was a he-she manipulation.
When they got to
so you have a man and a woman, and then you give them one pronoun. Is there any kind of interesting thing in their fixations when the pronoun doesn't match, say, the expected? If it's one of the conditions where they're expecting the source or the goal, and the pronoun doesn't match that, what happens with their fixations? Is there some sort of delay and they're looking at the wrong thing and then they have to?
Right, so that would be similar to the ERP study. Are there any effects of surprisal when, say, you get source reference following perfective? Right. We're not seeing anything obvious there. I think there are more maybe sensitive statistics that we could do on it, but we're not seeing any obvious, whoops, I was at the wrong place, I got to revise. But that would be a sensible thing to expect. Yeah.
And just one other thing, since there's nobody there. Oh, there is, okay. What about the click data? So I know you said you wanted to keep them engaged, but I think it's often interesting to see what they actually click on to see what they think is the referent of the pronoun. Well, I guess it would be, oh no, I guess it's unambiguous, right? Because you always give it a she or a he.
It's always ambiguous.
Okay.
In experiment 1, it's always ambiguous, and that's why it's at ceiling. We were hoping that maybe there'll be a little bit of an error margin, but it's so small that it's not worth looking at. But thank you.
Hi, you asked a question in your talk, and it seemed like you actually wanted an answer, right? Which was about what analysis to use, because you had that very big time window. And we run into this problem actually in some of our studies as well, where we don't actually have a really tight prediction about when it's going to emerge. And you can always do what you did, which is just take the big time window and go with it. But what we've ended up doing in some cases is to take a technique that's used by the folks in ERP, right? And to actually take every single one of the time points and run a little t-test or whatever statistic that you want on every single one of the time points, right? Then figure out the biggest cluster where you get your relevant effect. In this case, it would be an interaction. No, actually, it wouldn't. It'd be a main effect, right? And then to go and do a resampling analysis to find out whether the probability of getting that many points in a row that show that effect is below 0.05. And there's some description of this in a paper that Hugh wrote up coming out of our lab. It's actually on autism, but it's Hahn, Snedeker, and Ragbagliotti, I think 2016 or so. Yeah.
Thank you very much for that suggestion. We've actually started looking into doing cluster-based t-test analysis. It's not looking promising for these data. I'm not sure I've quite mastered the technique yet, but we're not getting, I think that requires that in those individual bins you get substantial differences, and I think it works best if you have a relatively strong effect in a small window, but ours is so extended that we're basically getting lots of marginal windows.
So you don't want to play around with it, right? But if you're going in expecting to get very weak effects, what you would do is you'd set the original T level to be very high, right, like 0.2, and then continue with the same rule in terms of what counts as a cluster. Your overall, right, probability of false positive still stays at 0.05. So if you have a priori expectations of weak or strong effects, you can actually handle that.
That's very helpful. Thank you, and I'll have to get that paper from you.
Thank you.
Next speaker is Sion Yoon. The title of her talk is Contributions of Declarative Memory to Common Ground, Evidence from Amnesia.
So it is very well established in studies of dialogue that conversation partners formulate representations of what information they mutually know, which is called common ground. And while communicating, conversation partners jointly establish common ground and develop short and brief referential labels when they repeatedly referring to a series of entities during the conversation. So for example, when these two people describe a Chinese tangram like this, at the very first time, they use long expressions, including a lot of details. However, over the course of repetition, they end up using very short and concise labels, such as stair climber, as they establish common ground between them. So this common ground is known to be partner-specific. The speaker shows sensitivity to their partner's knowledge state and accommodate their utterances accordingly. So the speaker tend to use entrained term to the knowledgeable partner who shared common ground, but they provide more specific information to a new partner who is lack of knowledge for this image label. So this process of designing utterances to meet the communicative needs of one's addressee is generally known as audience design. Then how does this common ground guide referential expressions during conversation? So according to one classic theory of language use, it suggests that episodic memory representation plays a central role in theories of common ground. Thus, speakers need to access to episodic memory representations of shared experience and common ground in order to appropriately adjust utterances with respect to the current partner's knowledge state. So here we examine the hypothesis that episodic memory underlies representations of partner-specific common ground and evaluate whether amnesia precludes the ability to successfully formulate and use common ground while communicating. In previous studies, individuals with amnesia showed dramatic impairment in acquisition of a new episodic memory. However, one previous study by Duff and her colleagues showed that individuals with amnesia are able to acquire referential expressions in a communication task where they had to describe tangram images for a familiar partner. So in their study, they showed that both amnesic patients and healthy comparison participants were able to develop short and brief labels across 24 repetitive trials. And the rate of learning did not differ between the two groups. However, the use of referential form varied between the two groups. So healthy comparison participants frequently use definite expressions such as the camel after they describe the same images multiple times with the same partner to signal that the reference is a part of shared common ground. However, individuals with amnesia were more likely to use indefinite expressions such as a camel even at the very last trials. So this finding does not indicate whether or not amnesia represents these image labels as a part of shared common ground with the discourse partner. Instead, an alternative interpretation of this remarkable paired learning may reflect patients' egocentric knowledge about how they view the tangrams rather than reflecting the representations of common ground. So here we ask if common ground can be formulated in the absence of episodic memory for newly experienced events, and if individuals with amnesia are able to establish and use common ground, we expect that they should use common ground in a partner-specific way. So in our study, we had total 8 participants, including 4 individuals with bilateral hippocampal damage, and thus they had a severe declarative memory impairment. But there is no evidence of aphasia in this group. And also, we had 4 additional healthy comparison participants who demographically matched to each patient. And each participant was tested in a referential communication task, which consists of 2 phases, including entrainment trials, followed by test trials. So at the beginning of entrainment trials, the participants was given a booklet including 16 objects on each page. And the participant and an experimenter sat facing each other, and there's a barrier between them so they cannot see each other's booklet. And the participants was asked to describe each image to the experimenter, and then the experimenter's job was to rearrange images following the participant's description. And we repeated this task 5 times, and then while they are repeating the same task, the experimenter and the participants develop a short image labels for each item. And after the entrainment trials, the experimenter always left the room. And 2 experimenters returned for the test trials. So one was the same experimenter who participated in entrainment trials and thus knew image labels very well. But the other experimenter was a new participant, so he was lack of knowledge for these image labels. And on each test trials, the participant and 2 experimenters had a separate booklet in front of them. And on participant's booklet, it indicates the target item that they are going to give instruction to or describe to the experimenter by a black box. And also it identified the current addressee, whether it's going to be a female or male experimenter. We always have 1 female and 1 male experimenter to make them more distinguishable. So the participants give instruction to one of the experimenter at a time, and when the experiment was addressed, the addressed experimenter circled the target, and the other experimenter just proceeded to the next trial. And each experimenter was given instructions on half of the trials. So we analyzed the expression lengths that they produced to describe each image during the test trials. And also we analyzed the form of referential expressions during test trials, whether it was a definite expressions or indefinite expressions. So we predicted that if participants flexibly use partner-specific common ground, they should produce longer and more indefinite expressions to the new partner rather than knowledgeable partner. So here's the result. So that is our reference length during the test trials. So gray bar indicates when they give instruction to the knowledgeable partner, and then black bar indicates when they give instruction to the new partner. And there is a significant effect of partner. So participants in both groups produce longer expressions for the new partner compared to when they give instruction to the knowledgeable partner. And there is a significant interaction between group and partner that was driven by a bigger effect in healthy comparison group than patient's group. And the second analysis was referential form during test trials. So yellow indicates the proportion of definite expressions, and blue indicates the proportion of indefinite expression. Again, there is a significant effect of partner. The participants in both groups produced more definite expressions when they give instruction to the knowledgeable partner compared to when they give instruction to the new partner. But the interaction between partner and group was not significant here. So in the current findings, we report that individuals with amnesia successfully establish and use partner-specific common ground even when they had to alternate between the two potential addresses simultaneously. They adjust utterances depending on who they are talking to, which is indicating the presence of common ground. And this surprising finding suggests that partner-specific common ground does not require episodic memory representation. Then what is the mechanism of this? So the fact that amnesia patients were sensitive to their partner's knowledge state suggests that episodic memory is not necessary to establish and use partner-specific common ground. Then some other mechanism must support the ability to use languages that reflect partner-specific common ground in the absence of the ability to recall shared history or common ground. So one possibility we suggest here is that during encoding, individuals with amnesia may formulate a unitized relation between each image, label, and partner, which is an ability that is linked to non-declarative memory. So the presence of the original partner may function as a cue to retrieve these unitized relations and may guide reference expression while communicating. Even though amnesia patients demonstrated sparing in the ability to use partner-specific common ground, their performance was not as efficient as in healthy individuals, which is pointing to a role and the contribution of episodic memory to representations of common ground. And thus, we suggest that multiple memory systems, including declarative and non-declarative memory systems, both of them make unique and complementary contributions to common ground processes. So to conclude, studying neurological patients allows us to directly test contributions of a given memory system to representations of common ground. And our data shows that individuals with amnesia were able to establish and use partner-specific common ground, producing longer and more indefinite expressions to the knowledgeable partner. So episodic memory is still important, and it can certainly support reasoning about common ground in healthy individuals. However, we show that establishing and using common ground does not require episodic memory. Thank you.
Okay, this is lovely. I first have a sanity question, a sanity check question, which is it's really crucial that your amnesic patients don't recognize the knowledgeable person when they come back into the room. And so was that checked?
Yes, so their episodic memory is quite severe, and we did not ask specifically whether they remember them or not in this test, but we do not believe that they recognize a knowledgeable partner because they frequently ask like where they are and what the task is. And also in the other study, we explicitly asked whether do you recognize him or who knows what kind of questions at the end of the experiment, and the memory was at chance.
Okay, good.
So they did not recognize.
So the second thing is a sort of framing question. So you're talking about this as, you can situate common ground someplace other than episodic memory. But we know that these patients also have sort of, another way of describing this is that you can get common ground in sort of implicit memory, but not in conscious memory. And have you thought about, are there any benefits to thinking about it in that way rather than, this is episodic or not episodic? So.
Okay. Can you just like?
Sure. So amnesic patients, when you put them in a situation, they won't remember that they've been in that situation. But later, they'll actually demonstrate that they've learned something because they can prime right? They'll
Right.
show priming. So that shows that they haven't actually failed in all of their learning. It's just that they don't have conscious access
Right.
to what they've learned.
Yeah.
Right. And
Right.
so I'm just wondering whether it might make sense to start thinking about common ground as being a sort of implicit memory phenomena.
Right. So that is our part of claims that, common ground is not, common ground is not required episodic memory representations. But again, as our data shows that, amnesic patients' performance was not efficient or perfect as compared to when in healthy individuals. So maybe it requires both memory system, but still
One final thing. Oh, sorry, I didn't see you. Okay.
Yeah, so that question actually was one of my comments, so that takes care of that one. Another, this is more of a comment than a question, but it's something you might want to think about. Another population that might be interesting to look at in this task is autism spectrum disorder, because what I think, that's a population that doesn't have issues with memory, but they do have issues with audience design and like the social aspect of it. So I think what's going on here, I do think memory is obviously important for this task, but I think there's a lot more going on than that. I think it's also a very social task, and you have to have executive function and all this other stuff.
Right.
So-
Yeah, that might be really interesting to look around how those population may do this kind of task. But our main question was memory is necessary
Right.
here or not.
Right,
And
I understand.
Yeah. And then our patients and then this group has a normal range of executive functions ability. So, but as I said earlier, there might be really interesting question to look around and explore things.
Yeah, thank you.
So super cool. So surprising and everything, what I bet they couldn't do is something that was more along the lines of your poster today, right? Where if you took the same referent that they had described one way to one person, another way to another person, they would not get that binding, I'm going to guess. So it could be something that's like a familiarity-based signal that's doing things rather than actual binding of representations of things.
Right. So the next step we are still working on is that a similar version that compared to my poster in the afternoon is that so here the two experimenter has common ground, which is all versus none, right? So in current work we are working on is that the one experiment knows animal tangrams and the other experiment knows people tangrams. So we have two categories, and then two of them has some sort of shared common ground. So far we are still having collecting data, and then I analyzed one patient so far, and then it looks promising some sort of way, but I cannot tell given
Looks
one
like they're doing
participant.
it?
So the thing is that to describe people tangram, it's quite hard. So during the people tangram, there's no effect at all. But animal tangram, it's quite easy to describe things. Then there is a person-specific effect there. So, yeah.
Yep, that's right.
Our next talk is Alessia Jareflev, who will be talking about tracking co-listeners' mental states during language comprehension.
Okay. So when we communicate, we constantly model states of mind of people we communicate with. Listeners consider their speakers. Can we hear it? Okay, sorry. So we'll start it over then. When we communicate, we constantly model states of minds of people we communicate with. Speakers consider their listeners when they design their utterances. For example, in this situation, Susie, a speaker, thinks what Mary knows about the situation they are in, what she knows about the project, to decide how much she should tell to Mary and what kind of details she should provide. Mary also takes into consideration everything she knows about Susie, including her emotional states, and uses this information to decide what is her opinion about Susie's idea. In prior research, strong evidence that communication is a joint action of a speaker and a listener has been provided. What is the role of co-listeners in communication? Rob, or Bob and Lucy. Do listeners track mental states of individuals who happen to be present during a communicative act, but who do not participate in this act in any way? Will Mary pay attention to mental states of Bob and Lucy, and will she use this information to interpret Susie's utterance? Rochma and colleagues propose that communication is in fact a joint action of a speaker, a listener, and co-listeners if they are present. They came to this conclusion based on an ERP study where participants completed a sensibility judgment task while they were accompanied by confederates. On each trial, participants heard a context sentence. For example, in the boy's dream, he could breathe underwater. This sentence was available to participants, but not to confederates. And then a target sentence was shown on the computer screen. The boy had gills. Participants were asked to decide whether a target sentence makes sense to the other person. Target sentences in the critical condition were implausible for confederates, but they were plausible for participants. Nevertheless, it was reported that participants' brains responded as if they couldn't understand target sentences in this critical condition. And the authors of this paper refer to this phenomenon as the social N400 effect. How does this effect relate to the classical N400 effect that we all know about? N400 is a negative going ERP component, which it peaks around 400 milliseconds, and it's observed in situations when participants experience difficulty in semantic processing. The social N400 component is observed in cases when participants identify that someone else has difficulty in semantic processing. The conclusion that Rochma et al. Made that co-listeners and co-readers impact communication is limited to a certain extent, because in their study, participants were explicitly asked to model state of mind of confederates. It is an open question how pervasive this effect is and whether it characterizes our everyday communication. In our research, we asked a number of questions. So the first question is whether this effect is robust. The second one, does it obtain spontaneously? And finally, does the magnitude of this effect relate to social abilities? The design of our study was very similar to the one that Rochma et al. Used. The key manipulation is a presence of another individual, a confederate. In the alone block, participants were tested alone. They completed sensibility judgment tasks and reading tasks while we recorded their ERPs. In this situation, it is unlikely that they are modeling anyone's state of mind as they are alone in the testing room. And then in the joint block, they were accompanied by confederates. Confederates were seated next to participants. They completed the same tasks as participants, but there was no direct interaction between participants and confederates. In this situation, participants might start engaging in theorizing about states of mind of confederates. There were three types of sentences that were presented to participants and confederates. First, they processed sentences which were semantically normal, such as, my car has new wheels now. We don't expect that these sentences should be difficult to process for participants or confederates, so these sentences are used as the control condition. Then, in the semantic violation condition, target sentences are semantically implausible. My boat has new wheels now. Information that participants received in context sentences, for example, I decided to paint my boat, do not help participants in understanding these sentences. So in response to the semantic violation condition, we expect to see the classical N400 effect. And then in the critical condition, target sentences are semantically implausible if taken in isolation. My boat has new wheels now. But you could make sense of these sentences if you have access to disambiguating information provided in context sentences. I decided to turn my boat into a car. In the alone block, these sentences, target sentences, should be plausible for participants, but definitely they are implausible for confederates who do not have access to disambiguating information. The key question in this research is how participants will behave in the joint block when processing sentences in the critical condition. If they do not track state of mind of confederates, then their performance in the joint block should be exactly the same as in the alone block. Alternatively, if they are sensitive to the fact that confederates cannot understand target sentences, then we might see some ERP patterns of semantic comprehension difficulty in participants' data. So this approach was applied across 2 experiments where 42 individuals were tested, and these were all adult neurotypical individuals. In each experiment, there were 2 alone blocks and 2 joint blocks, and 2 different tasks were administered across these blocks. Task 1 was a sensibility judgment task. In experiment 1, in the alone block, participants decided whether target sentences made sense to them, so they took their own perspective. In the joint block, they decided whether these sentences made sense to the other person. In experiment 2, we did not instruct participants whether they should make this sensibility judgment based on their own perspective or perspective of the other person. Task 2 was a reading task. In experiment 1, they passively read sentences, no behavioral responses were made. In experiment 2, they read sentences and answered yes/no comprehension questions. Okay, so next I'm going to show you brainwaves evoked in response to the semantic violation and critical conditions compared to the control condition. And the brainwaves that you are going to see will correspond to averaged activity over centroparietal electrodes. First, let's look at responses evoked in the sensibility judgment task of experiment 1. Let me remind you that this is a condition where we explicitly ask participants to model confederates' state of mind. As expected, there were robust N400 effects in response to the semantic violation condition, and that's not surprising. There were no significant differences in response to the critical condition compared to the control condition in the alone block. And this suggests that participants accessed disambiguating information provided in context sentences and used it to make sense of target sentences. Most importantly, we observed that responses were more negative to the critical condition compared to the control condition when participants were joined by confederates. This replicates previous findings by Ruishmaier et al., and it suggests that when you ask participants to think about someone's state of mind, they are able to do that, which is nice. But will we see this effect if we do not really ask them to model anyone's state of mind, if they just do sensibility judgment task? And we still observe it in the joint block, although the magnitude of this effect was reduced in experiment 2 compared to experiment 1. What about a more passive task where we do not draw attention to sensibility of sentences? In the passive reading task, there was a trend to the social N400 effect in the joint block. However, statistically, this difference between the control and critical was not significant. And there was no evidence for the social N400 effect in the comprehension task. To conclude, we found some evidence for the social N400 effect. Most importantly, we demonstrated that in some circumstances, this effect may be observed even when no specific instructions to take co-reader's perspective are given. Why was there no social and 400 effect in the passive reading task and comprehension tasks? I can only speculate. It might be due to lack of attention in the reading task where there were no behavioral responses. Or maybe mental load was too high in the comprehension task, and there were just no cognitive resources left to devote to perspective taking. But overall, this result is consistent with previously reported finding of attenuation of the perspective taking effect in non-interactive paradigms. The final question that I had in this line of research is whether the magnitude of this effect relates to social theory of mind abilities. And indeed, we found that social competence, as measured by the autism spectrum quotient, predicted the magnitude of this effect. Neurotypical individuals who we tested, who had lots of autistic features, and especially those who had difficulty in socializing, were less likely to engage in this perspective-taking behavior. In an ongoing study, we examined whether this effect would be attenuated in individuals diagnosed with autism spectrum disorders. So there were a number of questions that we asked, and we found that social N400 is a robust phenomenon. It, in certain circumstances, can be obtained spontaneously, and the magnitude of this effect relates to social abilities. I would like to conclude that passive co-listeners, co-readers, do have some impact on how a communicative act unfolds. And that's it. Thank you.
Yeah, I have a real quick question for you. I was just wondering why you don't have a control condition where the confederate knows. Because you're saying in your experimental condition, the main person thinks that the confederate doesn't know. So I was just wondering why you didn't have that as control
Why
condition.
would we need this condition? So because pretty much...
Because it's social, but it's not, I mean, so it's social, but you wouldn't expect to see the social M400, right? I mean, because the alone condition, it's not social.
Right, but our control condition is plausible for confederates as well as for participants. So it's pretty much what you are suggesting to do, right?
Yeah, I mean, not quite, but...
Because in the control condition, there was also some context information provided to participants, but it was not needed for comprehension. So really, to understand these sentences, you only needed target sentences. And these target sentences were provided to participants as well as for confederates. And participants knew that confederates in this situation can understand these sentences. They don't have any difficulty in understanding them.
Yeah, all right, I'll give that some thought, but I don't know. I still think it would be good to have it, but.
Thanks very much, that was really cool. I've sort of a clarification question. I couldn't remember, you asked them to judge whether this sentence was going to make sense to themselves or to the other person. Was that something that you manipulated in the condition where you had them working with where there was a partner? Did you ask them both of those questions or just one or the other?
So we had two experiments, right? In experiment one, we used this we used a type of sensibility judgment task where we explicitly told them whose perspective they need to take, either their own or the confederates. And so that was used, so we tried to replicate Roche-Myers et al. Study, and that's what they used. So that was pretty much the point.
But here you only reported the results for, I mean, I didn't see that in the way you reported the results. You told them either to think about their own perspectives or their confederates.
Yes.
But I think you just collapsed the results when you presented them here.
No.
Maybe I didn't follow
Yeah.
that.
So let me just tell you.
Sorry if I missed that.
That's okay. So in the alone block, when they were alone, they received instruction. Does it make sense to you?
Right. I meant in the joint block, did you manipulate it?
No, in the joint block, it was always, does it make sense to the other person?
Right. Okay. I thought you had asked either one of the questions, and so I was just wondering.
And then in experiment two was just, does it make sense? It was up to them to decide whether they should take their own perspective or perspective of the other person.
Thank you.
Yeah.
Our final talk is Shane Sloggett, and he'll be talking about animacy and reflexive pronouns when it matters more than verbs.
All right, so I'm talking today about reflexive pronouns, which have been a little bit troublesome for recent models of online dependency formation, in no small part because of variability in the literature with respect to how these things are treated. So while a lot of studies have found that comprehenders are very strictly applying grammatical principles when they're resolving a reflexives reference, there's a minority of more recent results which seems to show that comprehenders, at least occasionally, are attending to putatively ungrammatical reference. In this talk, I'm going to hope to make 2 points. The first is that to understand variability in reflexive reference, we really need to understand something about the discourse constraints that obtain a reflexive antecedents. And the second is that, oh, that's not good. Good enough. Okay. So the second is that perspective taking is sort of the critical piece of information necessary to understanding what's going on in these studies. So to give you an idea of where we're headed, I'll begin with a brief overview of reflexives. So we'll be looking at the grammatical constraints that hold of them, as well as their representation in the sentence processing literature, before looking at evidence that reflexives are actually sensitive to discourse properties as well. I'll then present 2 new experiments. One of these is an interpretation survey, which shows that people are actually getting non-local interpretations of reflexives even when they don't have to. And the second is an eye-tracking little reading study showing that these reflexives are actually tracking perspective holders in an utterance. I'll then end by trying to make the point that we should be tying this to logophoricity in some meaningful sense. Okay, so if you think back to your syntax 1 classes, you may remember that reflexives are supposed to be distributed according to principle A of the binding theory. Principle A says roughly something along the lines of a reflexive pronoun must refer to a C-commanding referent within the minimal clause, simplifying slightly. And we can use this to understand the distribution of judgments for sentences like 3. So Bob said that Jean's friend embarrassed himself. Most people agree that himself here has to refer to the entire phrase Jean's friend. It can't refer to Jean because Jean doesn't C-command the reflexive, and it can't refer to Bob because Bob is not local enough. In the sentence processing literature, a lot of investigations of the online application of Principle A have used something called the mismatch paradigm, an example of which is given here in 4. So we can talk about targets as being those references that are compatible with Principle A, which comprehenders should be paying attention to when they're trying to identify a reflexive's antecedent. And we can talk about manipulating the features of the target so that it either matches or mismatches the reflexive pronoun. In contrast, we can also talk about lures as being those antecedents which are incompatible with Principle A. And again, we can manipulate the features of these things so that they match or mismatch embedded reflexives. And the degree to which we observe a difference between lure conditions indicates that people are violating Principle A in the course of resolving the reflexives reference. Specifically, we'll be interested here in lure match facilitation effects. So these are effects which occur when a feature-matched lure actually facilitates processing of a reflexive which mismatches the target antecedent. So that would look like Stephen facilitating reading times for himself in this case when the local subject is something like girl or girls. There's a lot of studies now that seem to fail to find any evidence of lure match facilitation, seeming to indicate that comprehenders are quite reliably applying Principle A to their interpretation processes. However, there's some recent evidence from Parker and Phillips who do find a lure match facilitation effect when the reflexive mismatches the target in more than one feature. In other words, when the local antecedent, girls in this case, is a gross feature mismatch for the reflexive pronoun, you're willing to consider things up in the position of Stephen or Susan there. So while feature match may be an important part of the story here, I'm going to argue that elusive sensitivity to lures may also be due to additional discourse constraints on non-local interpretations. So in particular, there's a lot of variation in terms of which verbs are used to embed reflexive pronouns across these studies. And looking at a handful of them, studies which fail to find lure match effects or lure match facilitation effects predominantly embedded reflexives under belief or perception predicates, so things like think or hear. In contrast, Parker and Phillips, the strongest evidence of a lure match facilitation effect to date, mostly embedded reflexives under speech predicates, indicating that lures may be more attractive when they're acting as sources of information for some reason. In a previous study, previous eye-tracking study, we actually went after this question directly by manipulating the embedding verbs, that it was either a speech verb like say or mention, or a perception verb like hear or see. I've plotted here, and you can't see it, of course. Go past reading times at the embedded reflexive region. I'd like to draw your attention first to this right set of bars, the perception conditions. These indicate that when the embedding verb was a perception verb like here, people weren't paying very much attention to the matrix subject. In fact, they only read the reflexives more slowly if they mismatched the embedded subject, regardless of what was in the matrix position. In contrast, when we look at the speech verb conditions, reflexives under speech verbs were read quickly as long as they matched one thing in the sentence, regardless of whether or not that was the lure or the target. So descriptively, these findings seem to indicate that lure match facilitation is at least partially dependent on the verbs used to embed reflexive pronouns. And this is consistent with other work which finds that reflexives are preferentially referring to sources of information. If you think about it, subjects of speech verbs tend to be sources of information. However, these findings fail to establish that comprehenders are actually entertaining non-local interpretations of reflexive pronouns. That is, there's no way to distinguish between the two possibilities, one in which reflexives are finding a long-distance antecedent, and another in which they're simply checking their syntactic features at a distance. We addressed this in experiment 1 by taking the same materials from that first study and adapting them to an interpretation survey. So we collected some people from Mechanical Turk, asked them to read these sentences in a self-paced reading fashion, and then asked them a comprehension question afterwards. And critically, when the embedded subject, the target antecedent, matched the embedded reflexive, we actually asked them to a comprehension question which targeted their interpretation of the embedded proposition. So in a sentence like, the nanny said that the girl lied about herself, we would ask them something like, who did someone tell a lie about? And they'd have to then give us the answer, the nanny or the girl. Depending on their way they answer this question, we have information about how they've interpreted the reflexive pronoun in these situations. The table here gives you the mean proportion of lure responses, or in other words, how often they took the long-distance interpretation. The first thing I'd like to draw your attention to is that there's an overall effect of speech versus perception verbs, such that we're getting more matrix interpretations when the embedding verb was a speech verb than when it was a perception verb. You might then reasonably be worried about the relatively high rates of matrix interpretations, even when the matrix subject doesn't match the embedded reflexive. I suspect this has something to do with stereotypical gender, but in the interest of time, I'll leave that for the discussion section. The important thing is that there were more lure responses in speech verb conditions than in perception verb conditions. So qualitatively, this seems to replicate the effective verb type found in our original study. Moreover, it tells us that comprehenders are willing to assign non-local interpretations to reflexives, and that they're more likely to do so when they're embedded under speech verbs. Critically, they're assigning these interpretations even when the target antecedent is a perfect match for the reflexive, unlike what we were seeing in the eye tracking data earlier. These findings also mirror some other work by Kaiser and colleagues showing that reflexives are preferentially referring to sources of information. So there seems to be mounting evidence that reflexives are sensitive to something like discourse information, possibly to the discourse roles of their antecedents. And this means that we need a slightly better understanding of what's going on in these situations. Which parts of the discourse are reflexives actually responding to? And I'm going to present you with two hypotheses. The first of these says that comprehenders are preferentially interpreting reflexives as referring to a source of information. That is, they're targeting a particular thematic role in the discourse. Alternatively, we might believe that reflexives are targeting the perspective holder of an utterance. And then to understand previous results, we might say something like, okay, speakers or sources of information typically make better perspective holders than other people. These hypotheses make different predictions for what we expect in the future. Notably, under hypothesis 1, a reflexive should uniformly express a preference for referring to a source, regardless of how many perspective centers are in the utterance, or perspective holders might be in the utterance. The reflexive is going to target specifically that thematic role of the discourse. In contrast, under hypothesis 2, thematic roles should only really influence reflexive reference when there is more than one potential perspective holder in an utterance, in which case you might expect the thematic roles to push you to favor one person over another. We're going to test this in experiment 2 by replacing our embedded subject with an inanimate pronoun. So notably, inanimate reference, things like it, can't hold a perspective, lacking a brain, it's a little difficult. So critically, in sentences like 8 here, the lure is the only possible perspective holder in the utterance. The question then is, do we still observe an effect of verb type? Under our first hypothesis, if reflexives are referring to sources of information, we should still observe an effect. There's still a difference between the actress being the subject of say versus the subject of hear. In contrast, under hypothesis 2, the fact that the lure is the only perspective center in the utterance should obviate the effect of verb. We manipulated sentences like 9 here in an eye tracking while reading study. So there was always a context sentence, something like the salacious journalist or article was widely derided, followed up with a target sentence, the actress or actor said that Jill lied about herself. In our grammatical baseline conditions, the embedded subject was simply a proper name that always matched the reflexive, and we didn't actually manipulate the embedding verb for these conditions. When the embedded subject was an inanimate pronoun, however, we did manipulate the embedding verb to see if that effect would survive when the lure is the only potential perspective center in the utterance. I've plotted go past and total reading times for you here at the reflexive and embedded spillover region. I'd like to draw your attention primarily to go past and total time at the spillover region and total time at the reflexive region, where we see basically the same qualitative pattern across all three measures. Focusing first on the blue sets of bars, those are the cases in which the embedded subject matched the reflexive. We don't really notice any particular effect of the matrix subject. That is, people aren't differently reading the reflexive depending on whether or not the lure matched the reflexive. The gray and red bars here are the cases where the embedded subject was it. Gray bars representing the speech verb conditions, red bars representing perception verb conditions, and for both of these, we're observing fairly strong lure match facilitation effects. In other words, comprehenders are reading reflexives and the spillover region slightly faster when it matches the lure antecedent than when it mismatches the lure antecedent. Notably, this doesn't seem to be different across the speech verb and perception verb conditions. That is to say, it looks as though animacy is obviating the effect of verbs. So when the lure was the only perspective holder in the utterance, we failed to find any effect of the verb type. And these findings suggest that reflexives don't uniformly seek out source antecedents. We saw no evidence of a difference between goal or information goal lures, information source lures. So targets or reflexives seem to be targeting the perspective holder of the utterance. What this means is that we may need to revisit previous findings that did find a difference between speech and perception verbs and reinterpret that as telling us something about how people decide who the perspective holder of an utterance gets to be, or who gets to be the perspective holder of an utterance. So given this sensitivity to perspective, variation in reflexive processing starts to look fairly similar, actually, to cross-linguistic variation in pronominal reference. And in particular, it looks as though comprehenders may be treating reflexive pronouns as though they're logophoric pronouns. So for those of you who have never seen this word before, logophores are pronouns which necessarily refer to the person whose speech, thoughts, or feelings are reported in an utterance. Cross-linguistically, they tend to be, or they can be at least, homophonous with reflexive forms. So in languages like Mandarin Chinese, the reflexive form ziji is argued to be logophoric in at least some cases. Notably, logophores are attracted to perspective holders of an utterance and preferentially refer to those particular roles in the discourse. So these findings look as though they're joining in a growing body of evidence that reflexive processing really is sensitive to logophoric constraints in a meaningful way. To wrap up, since I'm out of time, several studies now find that reflexive comprehension isn't always constrained by principle A, so contrary to what we used to believe, and moreover that discourse information seems to be impacting the likelihood of principle A incompatible behavior. The findings I presented to you today suggest that reflexives can be given principle A incompatible interpretations, and that they aren't just attracted to particular thematic roles, but are rather tracking perspective holders. Moreover, thematic roles may be influencing the selection of this perspective holder, and it looks as though we might be able to get some traction on understanding this variability by looking at logophoric pronouns cross-linguistically. Thank you.
Let's let junior people first.
Thank you. Thanks so much. This is really interesting. So anecdotally, it seems like there's some variation in how people use reflectives in various contexts. So for example, some people can say, you know, something like, please come talk to myself, and other people can't. I don't know anything about the actual data about how these are being used, but I'm wondering if it's possible that there's actually, that we're seeing language change in progress with respect to how people use reflexives, both in the case I mentioned and potentially here as well. I was wondering if you have any thoughts on that.
Absolutely. So there's actually some really interesting data from Sarah Loss, I think out of Minnesota, who was looking at Iron Range English, which is a dialect of English which is actually fully grammaticized long-distance reflexives that behave very similar to what we're seeing in online measures for standard American English speakers. So it does seem to be a point of language change in progress.
Awesome. Thanks.
I'll just follow up on that. If you spend any time in Rochester or Buffalo, you will often hear people say you can just, you know, if you're confused about this, you can ask, with lots of stuff, but a reflexive pronoun back to the singular first-person pronoun. It's really prevalent. The point I wanted to make is that you were mentioning that these violations of Condition A are sort of a recent finding, and they're not. I mean, so CUNY has a very old paper, 1982, and the nice thing about it is it sort of fits with your general story. He was actually looking at those pictures of himself constructions and noticed that, you know, people don't always do what Principal A suggests they're going to do. And what he pointed out is that they work best when people take the perspective of the camera. And so I think this just fits nicely with your entire kind of perspective story, but you probably want to widen your view to including those additional phenomena.
Yeah, thank you. That's a really good point, actually. The thing I didn't mention in this is critically, all of our examples are actually direct object reflexives, or which are not supposed to behave like this. So the work you cite is also relevant for things like Pollard and Sogg, or Reinhardt and Royland, who have entire syntactic theories built around accommodating these apparently contradictory uses of reflexives. What's somewhat new about this data, and what was new about the processing data I was mentioning at the beginning, was it was the first time we had seen direct object reflexives, things that aren't supposed to behave as though they're principal A violators, behaving in that way. And that was sort of the interesting finding that I was trying to highlight, but thank you.
Okay, the conference is now officially over. Please get your stuff. If you have any stuff downstairs, no one's going to be watching it from this point on, so I highly recommend you take it with you. And then we have this pizza, there's free pizza and beer and wine and soda and water over at the poster area until 8 p.m. when we have to cut off drinking, so that we can, the alcohol can be served until 8 and not after that. So plan accordingly. Double fist if necessary.